I
See if
can
I can.
barely go on TikTok.
Yeah, let me see if I can stream to YouTube here. Share link. Here we go. Not the button.
I got the TikTok link in the main chat. Took a while to get off mute, but in main chat should be the TikTok link.
All right, there we go. There's 0 frames drop, so I think we're good on TikTok then, allegedly. Shane, are you there? Oh. Oh, I need to bring him up on TikTok now.
Yeah, you're just echoing in here.
Yeah.
There we go.
Yo, my bad. I totally forgot I had a secondary function here, and that was to bring you up on stage.
Yeah, it was like you have to do the thing that does the whatever thing, because I've never seen it or done it.
Yep, and the issue was me. Welcome, Shane. Welcome, Kat. I extended an invitation to our boy Gene Techman. Never met the man, but I've heard a ton about him.
Yeah, I'd like to hear him speak because you got accused of him of being him, so he must be super cool. I'd like to see what he has to say.
I'm just assuming he's one of the coolest people ever to grace TikTok, based on how everyone talks about him.
Gene.
I mean, remember getting accused of sounding like Witsit? And it was like, oh, what an insult. Oh, you got me. Like, oof.
I remember my first How Meth met reality prezi. Dr. Parks was like, you sound like Witsit. You just memorized a bunch of stuff or whatever. It was like, cool, man. Like, I guess.
Yeah, dude, I remember someone being like, oh, you just memorized a bunch of stuff so you could, and I was like, to say that to a random person on the internet? Really? Really? That's what I spent my it couldn't just be that I naturally knew that and like recalled it to you, no? I had to memorize it to impress you. Like, what kind of, come on.
Knowledge is power, lads and ladettes. And today we're going to bring some knowledge. A popular discussion as of late has been mountains and shadows on the tops of mountains and whether or not this proves a globe or not. Now we're on one aspect of a multi-pronged argument here, but we're going to look at one aspect of it in particular is, would this shadow still be cast by the mountain if it's not connected to the thing above that it's casting the shadow on? So the demonstration that we gave the other day, the pyramid was touching the surface. So now we have a demonstration where it's not touching the surface, and we can finally put this to bed. This is a 5-year argument. All this has been available. And also this has been modeled out by a civil engineer, which we'll watch a little bit of before we move on. But yeah, if you know any globularists out there, I encourage you to tag them and share this, and we'll bring them up and have a little discussion about it. Yeah, we'll go ahead and get started. So shout out to our boy Gleam, who brought this little piece to us. Totally forgot about it. But here we go. This is exactly what was asked for. Will the shadow still be cast?
well. That seems to work fine.
Yep, we got another one here. You could find these, by the way, by going to YouTube, typing Chris Berry. Oh, hold on. There's an additional step. Get you the exact thing. At twitface with a 1 instead of an I for the twit. If you type at twitface with a 1 instead of an I, you will come across this man's channel. Go here and type shadow. And then you can watch all of his shadow videos and have access to them. All right, so now we'll continue on here. All right.
Conclusion.
What's your conclusion so far, Shane?
Light so must be above the mountain, and Earth must not be curved. That's crazy.
Interesting. Well, let's see what we have for the follow-up here.
Hey everybody.
Can you guys hear the audio, by the way,
Quick video here, just
on TikTok? Shane, can you hear the audio on
wanted
this?
to
Yes, I can hear the audio
bring up
fine
this
from the
image
video.
Oh,
that
okay, cool.
the round Earth community has been putting out lately and saying this can only happen on a round Earth because, you know, if the light source is above the object, it wouldn't cast a shadow underneath the clouds. And I mean, I've known for a long time that's been wrong, and every time a round Earth person says that, I've asked what they've done to confirm if that's even true, right? They like to make these blanket statements like, oh, sunsets aren't possible on a flat Earth, light under clouds and shadow on the clouds aren't possible on a flat Earth. These blanket general statements, they have absolutely no idea if that's even true or not, because they've done no tests or experiments themselves. So I was sort of put to challenge by a couple ball earthers to see if I could replicate something like this. And well, I did, and it was really pretty easy. So I'll just bring up a quick image. I do have a video of this, but I'm probably not going to put the video on, at least not right now. Now this, and I pulled these up for comparison, just so you can see, and it even replicates the, if you notice, it sort of widens, the angle of the shadow widens as it goes out, and mine does too. Now here's the catch. Kind of hard to tell towards this end, but either way, it's the same. It's just very, very similar thing. It widens as it goes out. Now this was 4 feet above the bottom of the lid. Okay, so it's above the lid, so it's not below the lid. So the light source is above, and about 4 feet away. Okay, so above 4 feet and away 4 feet, and I got the shadow underneath the lid. The shadow is, I taped a paint stir stick to the bottom of it, and that's kind of what is here, and that's what's hanging down, and that's what's casting the shadow. So debunked.
Awesome. All right, sorry about that. My mic was muted. Let's see. Now we're going to look at the full engineering project that was simulated that I was trying to show the other day, or yesterday specifically, that was interrupted, so we can see exactly what was being discussed there. So here we go.
Right. My favorite.
See here the hard.
So yeah, for quick context here, an engineer, civil engineer, was intrigued by this whole Mount Canigou or Mount Rainier situation with the shadow being cast up. So he went, tracked down this picture, figured out where it would have had to have been taken from, and made a model to scale of this area and this mountain based on, and then to show what would have to happen if the Earth was setting due to physical obstruction of Earth curvature, i.e. dropping below the horizon.
Shadows that are cast, and as I move the light away, there is no effect on lighting intensity or the shadow sharpness. What does affect the shadow is the angle of the light. So this will be adequate for this experiment. So I built the model with two known caveats. The model would be scaled and the sun would be a direct light with the infinite parallel rays. Overall, this is not a compromise because the experiment is really to see if the globe/ball would also cast a shadow on the clouds as the sun went down.
All right, so this is extremely important, lads that are here for this. There's a second shadow that has to be present. This isn't just about does the mountain shadow cast up or down, right? There also has to be a shadow cast by the ball of the Earth, the actual curvature.
Really important to build a replica as much as necessary. These principles are really about angles, line of sight, etc. So the essentials to do this, in my mind, were as follows: a scaled Earth globe, a suitable light source such as direct CGI, a cloud layer, a scaled version of the mountain, and really the approximate location and orientation of this photo, the point of view from which this whole thing took place. So the next question was, where was this photo actually shot from? Looking at the site, you can see Mount Rainier in the background. Another prominent feature was the building just in the foreground. It's next to this small body of water. It turns out that it is the Theus Landing Waterfront Apartments. Also, another noticeable feature was the Tacoma Dome in the middle ground just to the right. And then just in front of that was the East 21st Street Bridge. So with all of these locations determined, I could look at a map now to try and approximate this photo location. So looking at Google Maps, we see here the Tacoma Dome. And if you pan a little bit north, you'll see the East 21st Street Bridge. And if you pan a little further north, you'll see this building here that's shaped like an E. It's the Theus Landing Waterfront Apartment. And if you look at the ground photo of the building, it is in fact the exact building. So if you pan the map up in the line of sight direction, you'll find this building here, which is the Tacoma Sign Company. So while I can't be 100% certain this is where the photo was taken from, it's definitely precise enough for this experiment. So if you zoom out over the whole entire site, this area is what I needed to replicate and build in 3D. Looking at the overall map of this site, we can get some rough dimensions from the location of the photo to Mount Rainier. The distance away from Mount Rainier is approximately 68.2 kilometers or 42.37 miles. You can also see a Google Map 3D view of the site with the prominent features in the frame. So here's the sphere Earth model scaled 1 kilometer to 1 meter. You can see here the radius is 6,371 meters. As we zoom way down into the model, we'll see Mount Rainier. All of this data for Mount Rainier and Tacoma are from DEM data sources, and they have been scaled to 1 kilometer to 1 meter. Now zooming over to Tacoma, you can see the dome, the East 21st Street Bridge, the Theus Apartments, and now you can start to see the location where the camera was placed in this model. So here I will select the camera that was actually set up to view the scene. And you can see now here is our final shot. For verification purposes, I've placed a couple measurement references in the scene. This first one is the height difference in the model from the photograph to the peak of Mount Rainier. You can see that it is 4.378 meters. Mount Rainier is 4.392 meters above sea level in our model, so our camera is placed approximately 14 meters above sea level. Now we can select on the measurement reference for the distance away. You can see that the length is 68.2 morning and the
All right, my bad, lads. I got way too far into the technical specs there. This goes on for quite a while. I mostly just wanted to show this part, but you see he's building the whole thing to scale as accurately as possible. He's not trying to misrepresent anything. He's in addition to the shadow casting of the mountain, he's trying to see if the earth ball would cast a corresponding shadow. And this is what he ends up modeling out here. So we'll go ahead and play this out. It happens pretty
sun
fast, so
is
we'll play it at
rising
normal
in the
speed.
east, shadow on the clouds. Phenomenon of the mountain casting the shadow on the clouds. Let's see what happens. As you can see, as the sun rotates up, it does in fact interact with the spherical Earth and cast a shadow on the clouds from underneath. Our experiment was set up to mimic the Earth as a sphere, the exact size and conditions for a shadow from Mount Rainier on the clouds, and the hypothesis that as the Earth rotates, the sun goes down below the Earth. If the Earth were a ball, this is what we should see under these special conditions. In fact, if the Earth were a ball, we should probably see this almost every night in some fashion or another. For a closer look at what's going on, let's go back to the schematic. If we pause the sun rotation right here where the shadow crosses the cloud layer just to the west of the mountain, here is the image of what we could expect to see. This experiment is a serious blow to the globe model. After working through this experiment, this is another in a long list of proofs that people can do for themselves. Each one of us can go out each morning at sunrise or each evening at sunset and observe this for ourselves. Do you see this shadow across the sky? For me, I've never experienced this visual in my life on this plane, nor have I seen any photos of this phenomenon to date. What I hear right above us.
Yeah. Then he goes on to give glory to God and has a really nice musical on the way out, but we're going to skip that. But yeah, man, this is, it's been modeled out. So the argument, no one's ever modeled, guys, this was years ago. This Taboo's channel has been deleted multiple times. This argument, this was back in, 5 years ago. So I think we can all move on from that. And it's been, now that it shows, that adds to the null hypothesis that this is a mutually exclusive geometric property of the sun always being above the horizon.
Yep, you got to love how they take something that happens in the observable world, declare it, exclusive to the globe model, and then when we go to model it, we're like, oh, not only does it not prove your model, it exclusively proves ours every single time. So now, whenever there's a Mount Rainier shadow issue, right, mountain or shadow being cast upward on the clouds, we have to look for where's the corresponding, giant Earth shadow that everyone should see every night that no one's ever seen in the history of the sun. And then, dude, but their answer is going to be like, well, we should never see it because I've never seen one, right? Because they're convinced that the world that they see is because it's a sphere. So whatever they see, it's because it's a sphere. It's going to be the biggest cog dis moment.
Yeah, and that doesn't even get into the additional arguments of how the shadows of objects on the ground should behave when casting their shadows.
Yeah, come to think of it, isn't it funny how 85% of the super truther communities became shadow experts for the 24 hours, but failed miserably at every single analysis and didn't know what the fuck a shadow would do in any circumstance.
They are tricky. They are tricky. That's
to be fair, hard to predict, but yeah.
All right, we got Miss Liliana up here. Is that the Flat Earth Ambassadress?
Actually, I'm AI replacing her.
Oh, no way.
Did
Yeah.
you get caught?
She got abducted.
Well, we'll have to AI you for the next time then. We'll just have to emulate you.
Hi, Sacred. I tried to join those people, but they told me I was a troll and didn't let me join.
What?
Yeah, you probably got associated with us or whatever. They don't want you.
Well, I think I have a reputation for not letting people get away with telling others that they're saying word salad, you know? That's my specialty.
Yeah, people don't like to be called on their own bullshit, and you seem to do that quite a lot. So, yeah, it's natural.
Dude, I remember one time Lily was like, hey, guy, if we wanted to hear the mainstream regurgitation, we could just go to Google and like do that anytime. I'm here to learn, and like if you don't have anything new to add, how about you just absorb the information that's being said instead of interrupting every 5 minutes or every 5 seconds to repeat the mainstream narrative that we all know and are familiar with.
Right,
Like,
dude, destroyed, devastating. That would be to me, right? She memed him in real life. She was like, "Hey, if I wanted your opinion, guy, I'd Google it myself. Shut the f up and let me listen."
You know what? I really like this Earth curved shadow should be falling on the clouds argument. I think
good one,
we
huh?
need to strengthen that one more.
Yeah, I would like to see a reciprocal globe Earth model showing actually why we shouldn't see it, or how it would make sense.
There, you know what? The standard has to change here because we're locked in like a full dead end here. They have to do their own null hypothesis now. Like going over ours and going, oh, we didn't do it right. You now have to show why it works or why it has to be your way.
Dude, I like celestial theodolite as an argument. I think we should outline that eventually, and we should get that truncated into like one meme.
Speaking of celestial theodolites, oh, I don't have it on this. Oh wait, I sent it to Kat. Let me see if I can get it. Nice. We have a fresh copy of the new one for Glowbusters. We have a little sneak peek.
So
Yeah.
wonderful that Dr. Mike blessed us with this gift.
He likes to give weapons to murderers, I heard, or whatever.
I'm really excited to hear his presentation.
Me too.
See here. Yeah, it's going to be awesome. So a little sneak peek. What he does here is taking the angle from his location at his house, 50.7 kilometers away, to a mountain that's at an altitude, or that has a height of 2,226 meters. There's an angle of 2 degrees and 31 arc minutes between them. That's what's created there. Now the globularist will say, oh, well, refraction is, raising the mountain up, etc. We got to introduce refraction. And we're going to find out if that's the case or not by using stars to occult the mountain. And if the star is occulting the mountain as it's seen, then we know that angle to the star is true, number one, and it's not refracted. And we also know that the mountain is physically there, because the globe would actually predict 2 different elevation angles. In addition to that, if we were to take this observer and move him to the top of this mountain, the angle to the star should change. That's also predicted by the globe. We're going to see that that isn't the case, and you can verify that because the star gets occulted by the mountain right here. And if you were an observer right here, you would continue to see the star straight out at the same angle. So this is the theodolite he used. This is supposed to be one of the most highly recommended theodolites in all of theodolitery. Then we'll look at the measurements here. So again, it goes over how he derives the angle for the 2.31. We have the refraction coefficient, obviously, that makes up the difference between the globe prediction and the flat Earth prediction. And wouldn't you know it, the globe prediction is supplemented by the refraction coefficient. Oh, okay. So how can we know for sure, right? Well, if these angles match up, then that means that the Earth is flat. So if we take this angle here, measured from the theodolite on the ground to this star that's occulting it, then we should have the same angle.
How far away was he from the mountain in the first observation again? No, 50 kilometers.
50.7 kilometers, yep. So yeah, here's the star, and it gets occulted at 6:27:25 p.m. And remember, we all have the almanac, we all have stellarium. So what he does to go out and verify this is first he found that the positioning was off, and that was because refraction is automatically accounted for in stellarium. And then once you disable that, you will have the actual true planar positions. What he shows is that it gets occulted at the correct spot that corresponds to the flat Earth angles. And then if you place an observer on the top of here, the star is at the exact same angle. So this is mutually exclusive to a flat Earth.
Dude, this is so elegant and beautiful. I can't believe this wonderful guy brought this to us, and then his own like special proof. It was like, here, have some ammo, and it's like, it's not even ammo. It's like fire charge super incendiary ammo. He's like, just for fun, here's an extra proof. Literally, like if you make an observation to the top of a mountain, right, and you see a star past that, and you're on a globe and you travel to that mountain 50 kilometers and look again at that star, you definitely should have an angle change. And in fact, it doesn't at all. So what that symbolizes is literally from 50 kilometers away to the top of a mountain, your elevation doesn't change the distance to that star, meaning that star is exactly almost in an equidistant web around you. And it's all flat Earth elevation angles to everything. There's no curvature or anything. I think what he said was it's backed up in stellarium as well, that if you turn off the default atmospheric refraction settings that they have, it will literally give you the same angle from the same distance, and it's confirmable.
Yep.
Hey, how's it going? Oh, I got to switch on to Wi-Fi. Be right back.
Dude, it sounded like we had an astronaut underwater. It was super hot, Mike.
Sorry, was that me? I'm echoing.
Yeah.
Can I ask a question? Are you guys in the middle of something or what? It's quiet.
Yeah, what up, man?
Oh, okay. So Shane, you're the one that. First of all, Space Audit. I thought he was going to send me a link to the website that you created. I never received it.
Well, no, he said that it was adl.place, and you could find all the stuff there. I remember him saying that to you. And his database is on the bottom called Alan's database, and my database is on the top called Shane's database. Very easy to find, 3 letters. You got it, man.
I thought he was going to message it to me. That's fine.
My apologies.
So Shane, no, that's fine. So Shane, you used Raleigh's criterion for. Can we go back to what Shane did using Raleigh's criterion to determine the radius of visual? I don't remember what he called it. The visual radius.
Absolutely. And what's your Rayleigh's under? Is it under 69 miles or
angular resolution? Accessible angular resolution in our world, because it's not like I didn't come up with it, right? That was from Life is Short. Angular resolution in our world is the name of the video. That's all the optics there. Also under equivalent is optics or angular resolution or Earth curve, which will give you the corresponding math and the formulas for the other other pairs of Rayleigh's criterion data to get the same angular resolution from the actual ratio that will yield the same radius either way.
That's fine. Well, I was talking about what you claimed. I'm echoing here somebody's mic. You put up an image. Somehow you got the radius of the Earth as a radius of, I forget what you called it, visual, like the limit we could see. What did you call it?
I think he's talking about the radius of the sphere from that conversation.
Yeah, well, I forget what he called it though. But anyway, I don't know how Rayleigh's criterion would lead to that. Rayleigh's criterion doesn't give you a limit on your vision. It's a limit. It's the limit, the angular distance between 2 points that you can discern. It's not about a limit to your vision.
No. But Rayleigh's criterion is one component to the formula that would deduce the radius, right? So R equals D over the tangent of theta, where R would be the radius of Earth and D would be distance to the horizon, which is why we spent so much time on the distance to the horizon, right? So
I thought you were a flat earther.
And then the theta would be the angular resolution. So how you get 3959?
You just said the radius of the Earth.
He's telling you how to get the 3959 number though.
You can call it the radius of Earth.
Okay.
You can call it the distance of our spherical R equals D over the tangent of theta. Right? So when we have tangent of theta, we have actually supplied the angular resolution limit, which is derived from the wavelength and the diameter and a ratio, right?
No, not right. That's not how that works.
Okay, go ahead.
Show me the triangle that you're using. The tangent of theta, which triangle is this?
Well, go ahead and show me how that's not how Rayleigh's criterion works, though.
Rayleigh's criterion gives you the minimum angle you can see between 2 points before they start to overlap.
Yep, you said that. I agreed.
Yeah, it has nothing to do with an angle. I don't know what angle you're using.
Well,
angle?
When you use Rayleigh's criterion to derive, say angular resolution limit, and we use it to get the angular resolution limit of the human eye, and we use a wavelength of 666 and the diameter of 1.2, and that's how we get angular resolution of about 0.21 degrees. So which we then use as the tangent theta. That's the theta for our D. R equals D over the tangent of theta to get 3959.
Yeah, show me the right triangle you're using though. Where is it? You're mixing things together. I don't think you're doing it correctly.
Well, no, I'm giving you exactly what you want, and you're not liking it. But sure, you want to see the picture.
I just want to see the derivation.
You have a specific link you want me to pull up, Shane? Or is this good? I thought you had a spreadsheet.
I just want to see the triangle that he's using and how Rayleigh's criterion comes into play. Because that doesn't make any sense.
Well, no. So we're using Rayleigh's criterion as one of our variables in the formula to derive the distance, right?
Where's the formula?
3959. R equals D over the tangent of theta. That's the formula.
So tangent's D over R. So where's that triangle at?
Yeah. Right here. Hold me. All right, hold on.
Yo, are you trying to pull it up on your phone, Shane?
Yep.
Oh, just send me the link, bro. I can pull it up on the big screen.
Oh, that's so much better. All right, hold on.
Yeah, that's what I was asking you earlier. Although my mic might have been muted. I was wondering why you didn't just do that.
So right here is how we're applying it to both sides, right? So we're doing.
I can't see what you're doing.
Yep. 1 second. I'm pulling it up.
Okay.
So this is what we're comparing: an optical derivation from distance to the horizon versus a geometric distance to the horizon on a sphere of radius 3959. You can see on the right, using Pythagorean theorem and the height above, the R on the right, you get the distance to the horizon simplifying to 1.225 times the square root of the observer's height in feet. And we have the equivalent derivation below it here. Oh, actually, hold on. This one too, Alan. There you go, that one. Going below it, showing the same equivalent derivation using the optical. So we've already derived 0.21 degrees, right? So we're using that angular resolution limit from the product of our Rayleigh's criterion in this triangle, and then we're using r equals d over the tangent of theta, and we're using the distance to the horizon. So we got tangent, 2 times theta over here. So we got tangent times 0.4, which is just simplifying to 3 miles over r, right? So r would equal 3959, super easy, because we got feet to miles, 12 feet over 3, and the bottom right over here, and then that equates to the same distance. Now, you can use the diffraction limit of the human eye on a flat plane to get the same distance to the horizon as you can on a geometric sphere of radius 3959 for a 6-foot observer. That is the whole point of the optic equivalence.
So, okay. So you end up with an apparent radius of 3959, which happens to match the radius of the Earth?
Yeah.
And that's just a happy coincidence?
Well, I mean, that's not my position. What do you think?
Well, no, I don't think that you're using Rayleigh's criterion correctly. I don't even know how
you keep saying that, though.
Yeah, how did you get that angle? You said that angle of, what was the angle? 2 point something?
Wait, what are you talking about? We got
the angle theta you were using.
Yeah. So we got two times theta over there, right? So we started with
what's theta?
0.021 degrees. So we got 0.04.
Where'd that come from, though?
Well, that's Rayleigh's criterion.
No, Rayleigh's criterion is a formula.
Which results in a angular resolution.
Depending on what you
limit,
plug
right?
into it, though. Hang on. Yeah. I need to look at what you're. Because it looks like you work backwards, or did you derive this or somebody else? Did you make this?
No, this is from Life is Short, and it's from his video Angular Resolution in Our World. And someone also took it and put it in a a Word document and published it. And people have attributed that paper to me as well, and I also did not write that.
Yeah, okay. So I think he worked backwards and determined the angle that would work to give us 3959. Because I don't see where that angle is coming from.
So here it is, right? Here's Rayleigh's criterion used in all its majesty with our parameters 666 and 2.16 for our normal predictable circumstances for the wavelength of orange red light, which is most resistant to refraction at the surface level, which is where we're going to employ it. And then the pupil narrows when focusing on distant objects, and usually has a range between, I think, 2 to 4 and then 4 to 8 in the dark. So we'll give it 2.
What does that angle mean to you?
Right, so we got, theta 1.22 times.
What does that angle mean?
Times the wavelength of the diameter, which gives us that 0.02, which is how we get the angle that you were asking about, right?
What does that angle mean to you, though?
Well, this, in this circumstance, would provide the angular resolution limit of something like the human eye.
Right. So how do you apply that how does that become the angle in the triangle? That's the cross section of the globe. That doesn't make any sense.
Well, you see, if you can go back to that second picture there, Alan, with the big circle on the right. Yep. So if you look at that one on the right, we're using that triangle as a sector, right, of the circle. You see it on the right?
Yeah,
well, because we're saying that would be the radius of our vision curving at that rate. So that's what we're estimating at. Yeah.
What does that even mean?
Well, see, if you look closely, way at the top of the right, it's got 2 guys looking at 6 feet observer, emulating on a tangent, staring at the observer's feet. And you can see at 3 miles, he starts to lose the observer, and then past 3 miles would be where you actually lose bottom up obstruction. So that's why you have 2 times the tangent of theta. Yeah, because that would complete the 6-foot observer, and it actually goes into it right there. It says
that's not what Rayleigh's criterion's about.
No, see, you keep saying that. We're already using Rayleigh's criterion as the angular resolution limit.
I know you're using it, but I don't see how. That doesn't make any sense.
Yeah, well, we're using it as the tangent of our theta, right?
Tangent of the theta?
Yep. That's where we're plugging it in. From our first formula, which is R equals D over the tangent of theta, right? That's what we said 7 times.
Yeah, I get you're saying that, but that's Rayleigh's criterion would not be that angle. And it just seems like he's put it in there and kind of cooked it backwards to come up with R.
It doesn't keep saying that, but I just showed you how we got it and how the math works. And your first objection was, I don't think that works. And your next objection is, I don't like how that works.
No, it's not
So-
that. It's that it doesn't. That's not how Rayleigh's criterion works. Rayleigh's criterion is the minimum angular resolution between 2 points before they start to overlap. It has nothing to do with this
Yes.
sphere.
Yes, but in application, right, when we're using on a
it's
flat
not being
plane,
applied correctly.
well, we are, because we're using that to
you're not.
determine the distance to the horizon, right?
No.
That's how exactly
That's
how
not-
you get distance to the horizon. Yeah.
No, it's not.
No, it is.
No.
Mark, do you mind letting Shane finish his sentence?
Yeah, I don't like the tone policing you give off every time.
Yeah,
Well,
it would
I
be
don't
nice though, all
Shane-
the same, if you would let him finish when he speaks.
Yeah, but Shane never finishes a sentence. He just
Well,
talks over me, so I
listen,
have to interrupt him. Sorry.
No, you don't. We don't interrupt you when you speak. So
Yeah, but I
reciprocate,
don't go on
please.
for long. I don't go on without taking a breath, which is what Shane does.
Yeah, well, I
Well,
would like to hear the full.
I would like Shane to take more breaks. Thank you.
You need a break.
Why
At least
do
let
you
him
do
speak for like
that?
10 seconds and then say, hey, wait a minute or something. Don't do it.
Well,
like,
yeah,
2 seconds. in, dude.
I will, but then I'll get accused of interrupting him.
All right, continue.
Who, me or Shane? I don't know why you're using that angle. That has no
Well,
application.
I don't know. Maybe go read the published document. Maybe read the Word document that lays it out.
has it
Maybe
been
read
peer
the
reviewed?
published database. You interrupted me immediately
Oh.
again. You can't help yourself, bro.
Okay, published by who? Self-published?
Did anyone else have any questions for this guy, or what's?
Yeah, I mean, dude, you're
obviously.
using some unpublished math, dude. What? And you know that's illegal, dude. You got a license for that? You got a license to apply
Hold on. Well,
how to derive
I
I
limited
don't like how
distance to
your
the
math
horizon?
works out. I don't like how your math works out.
Yeah,
Oh.
so
Well, no, I don't like how you're misrepresenting Rayleigh's criterion and just plugging it in as an angle.
You know, Nards, you think that someone actually physically went and measured the Earth. They didn't. It's all based on angular resolution to the stars, which is what we see with our eyes. Okay?
No. Not okay.
I don't know. It's kind of weird though, because we have all the math that supports that conclusion.
I'm gonna look at that, but it looks like it's worked backwards. And the angle of theta.
well, here's the thing, right? Theta equates to like 0.021 degrees, which is what we determine for the human resolution. However, if you don't like that, there are other tuples that work equivalently, which you can get like for radio telescopes, you can get for, I think, large telescopes. Hold on, let me grab the other sets of data that also equate to the same angular resolution limit, so that it really doesn't matter if you can say you cherry pick whatever the first parameters we gave. It doesn't matter because there are other parameters which we can use which equate to the same thing. So
This is what I was
the
saying.
better,
So he's gonna keep going.
the better move though would be
Well-
for you to educate yourself on our position before coming here and just saying nuh-uh.
Well, I'm saying nah to that diagram because it doesn't make any sense. Okay, so you say it was published. It's been published by the person that wrote it, or published.
I mean, it's available on the internet for free by me for you to read and educate yourself on my position in its entirety. That's what I mean by public.
Right now, what was the website? Or
There you go.
ADL dot place.
what is? I'm sorry. What?
ADL dot place.
So you said it published, which implies that.
Yeah, he
Somebody-
he just meant like published online, not published in a journal, bro.
Okay, so anyone could do that, right?
Yep, any old swinging dick.
Okay. So hang on, so I'm on Shane's database. Where am I going to?
You're going to what is it? Optics and resolution.
Optics, angular resolution. Oh, there you go.
Type search in there. Type optics, and then it should come up in angular.
I'll have to go to Shane's database, I think. But
It didn't come up right.
Yes, at the top of the adl.place link, there will be Shane's database is the
Yeah,
first
okay.
option there. And then at the very bottom is Alan's database, and then a variety of links in between them.
It was me. Yeah, if you just type optics, it'll be the first one that pops up. Optics, angular resolution, or Earth curve. and you can read all
got it.
about it. Yep. No worries, lad. Sorry about not DMing you. I totally forgot.
Okay. It's coming up. Page not found. Hang on. Optics, angular resolution, or Earth curve.
Yep.
Optics derived. This page does not yet exist. I'm not. Okay.
Well, I mean, the equivalent is how we're using it, right? Is we're using it as a diffraction limit. We're trying to say, based on the diffraction limit for a 6-foot observer, we're determining the same distance to the horizon for a 6-foot observer approximating it with a triangle, the same way you'd approximate it with a triangle using the Pythagorean theorem geometrically for the Earth curve horizon.
Do you know what diffraction is?
Yeah.
What is it? Are you looking it up?
Well, no, I'm waiting for you to ask a real question, dude. Did
So
you have
what is
like a
diffraction?
follow-up?
What is diffraction?
Dude, are we talking about the distance to the horizon, right? So when we have a visual limit for acuity, right?
You just
when we
used the
have
word diffraction. I'm asking.
Yeah,
what
yeah.
it is.
Yeah. So when you're looking out at the horizon and you have light traveling in a straight line, right? And you have deviation from that, from straight line propagation, that's what they call diffraction. So when we're looking at it from
Diffraction.
a 6-foot observer to the horizon, you would lose visual acuity at about 3 miles for a 6-foot observer with the basic angular resolution limit of the human eye derived using Rayleigh's criteria.
Yeah, diffraction is the bending of a light, the wavefront as a plane wave goes through a slit. That's diffraction. And also, can you hear me?
Yeah, you reading?
Yeah, I'm looking at you. So you've got the horizon distance calculation. I see a formula. I don't see where it came from. Square root of 2RH.
Oh, well, that's the unsimplified form of the Pythagorean theorem derivation for, distance to the horizon geometrically,
Well, that doesn't make sense.
Well,
The Pythagorean theorem wouldn't give you that.
no, it would. It would.
Where?
Right?
Where's
It's
the
basic.
derivation for that?
Holy crap, dude. Right? If you have R, right, being the radius, you could have, if you're standing on a sphere, if you're 6 foot above the sphere, you have the radius of that sphere plus your height, right, as one side of the triangle. And then your D would be distance to the horizon. And then your R would be completing it to the center of the earth, doing the other side. And then you use A squared plus B squared equals C squared to get the distance of the main big R, right? And then you can do that, which ends up equating to 1.225 times the square root of the observer's height in feet. That's how you get it simplified algebraically, right? That's one of the flat earthers' baselines.
Hang on, I'm going to check this real quick. I don't.
Definitely go Google that.
Well, I can just do the algebra real quick. It's not hard.
Well, I mean, I preferred for you to see that other smarter globers already know that's true before trying to challenge me on it, because it's kind of tiring.
Yeah, well, you should be able to explain the derivation, or you should have the derivation up.
Should I? Should I have it up for you?
Should
you
you
not know basic things?
should you have it
Really?
published, available for everyone of all time? Well, in Shane's
Should it be
defense,
on
it is published, right? Like, so,
You say published. That implies that it's peer reviewed.
it is
not.
easily
Well,
accessible
did you-
online and made available for your convenience. But anyway,
Did you-
let us
yeah.
know when you get back to that math
I'm
or
doing
whatever. Cool. Shout out to my boy Sacred out there in the chat. I see you.
Why is he not up here?
Dude, I sent him the invite, but he was like, I'm busy, bro.
You must be super busy.
I'm chilling. Like, I can only hang around and listen to the chat.
General Jones should take a mic. Offer a mic to General Jones. He's sitting there arguing with me. Yeah.
I do remember him being super aggressive in the chat. Someone
Lily,
get him up here.
Lily, you're very quiet. How do I make you not quiet?
I think General Jones needs a mic. General Jones, you should ask for a mic.
Invited a couple to come up.
Yeah, he's
come along.
He teaches English, but then he said you guys are talking word salad, so just wanted to see what his English was like.
Oh, he doesn't dabble in small crowds, bro. He's a
English teacher who needs a vocabulary lesson.
Dude, he's a main attraction Glober, lads. Dude, he's the one they've been hiding that has the good arguments. He doesn't waste them on low crowds or whatever he said. That's pretty tight, dude. Well, one day when we're big enough for you to join us, we look forward to hearing you out, man.
Yeah, General Jones, don't cheapen yourself in the chat here, buddy.
I can only text chat. You guys aren't quite big enough to have a voice communication with me. Like, what? All right, dude. Peace be upon you, brother.
And then Shane needs to breathe more between his words, or else they don't get it.
That's fair. He does say a lot of words really quickly.
Shout out to user blah 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 blah, who's number 2 gifter. We see you.
I gotta learn what all this
whatever
all about. Anyways, I'll ask you guys later when we get back home.
Yeah, Lily, we're out in public now. We're not home.
Hey, user. Thanks for all your support.
Come up and chit chat with us if you'd like. Appreciate the gifting. Appreciate the support.
General Jones, I don't play to small crowds. Oh my God. But I write and troll to small crowds. Okay. We get it. We get it.
The math checks out.
I see how you got it by ignoring h squared. Hang on one sec. Can you see my screen?
Second, I'll bring you up on the big screen. Expand, I think. Yeah, there we go. All right.
Okay. So you're just using the Pythagorean theorem, and then in the end, you're ignoring h squared. Pretty easy. So Shane, why are you ignoring h squared?
What the fuck are you talking about, dude?
This h squared. You ignore it to arrive at d. See? Here's a triangle. Here's the derivation.
No.
Can you explain? I guess not. It's like...
Yeah, you drew your triangle wrong, bro.
Did I?
Here's the real picture. Ready? And I mean, to be fair, if you looked at the page instead of trying to Google why it's wrong, you would have figured.
No,
it out.
I'm looking at
Well,
it.
hold on. Well, I'm talking. It's the very first thing, right? So I put it up here as the actual first picture on the webpage as the actual globe side of it. So hold on 1 second, right? Here you go. Very basic.
This is the triangle right here.
Yeah, you drew a triangle, but you didn't draw like here, bro.
The same triangle.
The big screen, my dude.
See? It's the same. Same triangle. Just oriented differently. Maybe that's confusing. See?
No.
See how it's the same? So why ignore h squared?
It ends up being g equals the square root of 2 times rh, right?
I know that's your conclusion. Why do you ignore h?
Yeah. Well, how come it simplifies to d equals the square root of 2 times rh, right?
Because you ignored h squared.
No, you got the same fucking conclusion, dude.
Yeah, that's approximately. That's because I ignored h.
I didn't ignore anything. I simplified it. I'm giving you, first of all, that's not even the simplified formula. You know that are you going to keep talking, dude? You're going to ask me questions and then try. Well, you're not really answering. What you're doing is trying to get little gotchas and trying to do stuff to not even get the answer. So what you're doing, no. What you're doing is asking questions.
Hey, please don't talk over each other. Hey,
shut the fuck up.
Let him respond. Guy, whatever your name is, Nard.
My name is Nard.
Nard, yeah. Just give him a second. Let him speak. When you guys talk over each other, nobody can hear anything.
Go ahead. I just want to know why h squared was ignored.
He's
ignored.
Trying to tell
it's
you.
Simplified. It's simplified, bro.
It's not
So the other way to look at it is 1.225 times the square root of the observer site in feet. That's another algebraic simplification of it, which would be equivalent. So
I'm talking about this one, though.
Are you saying I missed it because I didn't put it on the webpage, or what?
I'm saying you had no idea how it was derived. You're just parroting what you heard.
No,
you don't know why h squared was ignored. I know the answer. I just know you don't know it.
Yeah. Well, you're just saying that, look, this pre-simplified step is here, and now I can point it out, even though my conclusion is mathematically the same.
My conclusion is just what you had on your website. I forced that conclusion. This is not how math works. I can tell you why h squared was ignored, but you don't seem to know. So why is that? You said a Glober far smarter than me could explain it, but you can't explain it to me. Why is that? Confusing. Too bad. You should know where your own formulas come from.
Of course I do, dude. But I don't have to answer synchronizing questions to fuckwits on the internet who try to get gotcha. So did you have some other questions? Well, why is the conclusion the same, dude?
Because I ignored h squared. Because
the conclusion is the same, dude. It's negligible, right? Why else would you mathematically have to simplify it out?
Why is it negligible?
What do you mean? Why is it negligible?
Why is it negligible?
For the small angle approximation at that height, dude.
No, there's no angle in here.
Well, go ahead. Tell me why it's ignored. That'll change the whole.
H is very small relative to r.
Right, so it's negligible. That's what negligible means.
Yeah, but you didn't say that. You said small angle approximation.
Bro, hold on one second. One second. Hold on. Let's back up a second here. So, yo, Taylor, you're hot, Micah. Oh, 1 second.
And also,
yo, hold on. Wait. Before we move on here. So you were doing exactly what Shane just said you were doing, trying to get a got you on something that simplifies out because it's a neglected term. And
not a got you.
And you're like, I know why it was neglected, but the conclusion is the same and it's fine.
My point was not.
So we went through
this guy's Tourette's, Alan.
We went through all of this.
Bro. Hey, your Glober Tourette's is acting up. Can you go on mute while people are talking? That way your Tourette's doesn't interrupt the conversation.
Yeah. This is getting out of hand, buddy.
I literally said it was negligible. I couldn't understand the question because it was so dumb to me. And when we finally got there, you were like, "Aha! I got you." Like,
Shane didn't know where this came from.
It's negligible.
It's just so small compared to R. That's why it doesn't matter. And it's like that's literally what he's been saying when he said it's negligible.
Yeah, after I said it.
No, but he told you because it was negligible.
He said it was a
multiple times before that.
He said it was a small angle approximation. There's no angle.
No, yeah, that's right.
Yeah,
that's right. No, it's negligible, dude. That's the answer.
You said small angle approximation.
But I also said negligible, and then you said,
I don't think I said it like that.
Well, that's kind of what everyone heard.
Okay. So hold on. Just to recap, though.
This is a small angle approximation, Shane.
Yeah,
Yes.
Just to recap,
that's on the other
though.
side, bro.
This
It's on
is
the
not.
other side.
Hey,
It's on the other side when we're doing the equivalent
There's no
distance to the
angle in
horizon.
here.
There's a different angle.
I just want to illustrate that you don't know what you're talking about. That's my point. Not this. I don't care about this.
There's another angle on the other side for the diffraction limit comparison, right? That actually is the small angle approximation of theta. That's why I got confused and said that. My fault. I misspoke.
Are we done with the cartoon time? Did you have any proof of globe religion, or is this all you got?
Well, no, he doesn't understand the math in the first place, and he had to try and go look it up.
The math. I just
because he didn't know what the distance to the horizon was on the globe in the first place.
I just wanted everyone.
But every glober and every flat earther knows that the distance to the horizon.
His Tourette's is not even listening, bro. Shane, you just dropped this.
All right, hold on. Just muted everyone. Stop. Everyone, stop talking. Everyone, just relax for a second. So just to be clear here, the math checks out. It's fine. You were trying to get him on a gotcha point, which he answered, and now we're having a rigmarole on something that doesn't matter. Is there an actual contention with the math, or is this going to be the main point of it? If this is the main point of it, we're going to move on.
This is not the main point.
Okay, continue on now.
Shane doesn't know where the formulas come from. He said I drew the triangle wrong to begin with. Then he searched around for something. He didn't come up with anything. He couldn't answer me, and then eventually said H is negligible due to a sine approximation. That's a small angle approximation.
No, that's on the other side.
It's negligible. When you derive the period of a pendulum, Shane. Hang on, I'm not done. So this has nothing to do with this. I'm just illustrating that you don't know the words you're saying, and you're following what somebody else derived incorrectly.
So did you have an actual contention with the math, though? Are you going to get to that point, or are you going to keep reiterating about the other thing? Because if you don't have an actual point, then we're going to move on.
Yeah, well, I know you want to get rid of me, but this has nothing to do with the triangle that's drawn that Shane was showing me. Wherever it is, I'm scrolling through.
No, it does, because we're equating
Hold on one
to the other
second.
side.
I got you, dog. So it does specifically. And he showed you that, and your contention with the math was to try and get a gotcha, man. Thanks for coming on.
No, it was to show really that he doesn't know where the math.
Yeah.
Thanks, bro.
All right, cool. Globe guy McGloberson, you still here? It's your turn or whatever.
It's my turn or whatever.
What's up?
That wasn't a face.
That wasn't a very good intro.
Yeah, my bad. What's up, man? How are you?
Sorry, bro.
That's good. It's all right. Doing good. I was just enjoying that conversation.
Any proof of globe religion?
It would have been nice to get to the point sooner and then not go for like a point that's not irrelevant. And then when asked for the actual point of contention, it was just a reiteration of the gotcha. It's like that was like kind of, like not very satisfactory for me personally.
That's fine. I mean, Shane didn't know how it got to that point. I mean, I was listening the whole time, so.
And yeah,
I think that was his point.
How would the other guy have done the math? Like, what would his numbers have been? That's kind of what I was.
The exact same conclusion. That's why I was the confusion.
I think his point is you're taking other people's math and doing it that like.
He didn't claim
necessarily knowing it yourself.
Deriving Pythagorean theorem to get the distance to the horizon is nobody's specific math, right? Everybody can do that.
Well, I mean, apparently not, though, right? I mean, wouldn't you have known what he asked for? Look, it's a mute point. Anyway,
well, he asked a really stupid question, and it took me a while to realize what he was asking.
It wasn't a stupid question. He asked you what goes on with this h squared there. It wasn't a stupid question. If you knew how to derive it, you would have known what happened to the h, right?
Yeah, but it wasn't in the answer or his answer, so I was confused.
Okay. You have the right to be confused, but I think that does point out that you don't necessarily know the derivation yourself that you claim to have done, right?
Well, no, it means that he's asking a retarded. I mean, it's a silly question.
The questions were confusing that he was asking. He was asking.
He asked where'd the h squared go.
And in a gotcha
confusing.
format.
Yeah. Well, there's an equivalent thing would be like, hey, how come this pre-simplification step, three steps before here, how come this drops out? And the answer is the same every step because it cancels out or becomes negligible, right? So to point out one of those is kind of silly to me. And I couldn't really grasp that was his main point because he took 10 minutes to get there as he quietly researched it and had to go Google it to figure it out and compared it to the website before he was like, aha, I figured it out. I got the same answer. So I was just confused.
All right. That's Yeah, fair enough. I think to have certain conversations, it's okay to try to baseline the knowledge of the other person before you continue.
Dude, sitting there and asking gotcha questions is no way to actually have a conversation. If there's an issue with the actual information, that's one thing. But if you're just going to sit there and pester somebody, I mean, we could do the same thing to you, and I guarantee you would not be able to answer every single question. And plus putting somebody under pressure is not a good way to try to test their knowledge by like pressuring.
No, it is. That's probably the best way to do it. No, it's not. Interrogation
is one of the worst ways to retrieve knowledge from people.
It's not interrogation.
And studies have shown that you cannot accurately and actively retrieve knowledge to your best ability whenever you're being interrogated, bro. Seriously.
How is it interrogation when you're having a debate about a scientific topic and you question somebody's knowledge on that topic? How is that interrogation?
He's sitting there questioning Shane. He didn't he's just pestering him and constantly questioning him.
He had the same conclusion, and he made an argument about it. It was weird.
But that's so crazy, dude.
Yeah, and he had to go Google stuff. I mean, he showed what he was Googling. So he tried to come back with a gotcha question.
Do you know everything? I mean,
no,
I'm guessing you guys use Google a lot.
No, hell no. No, I don't know anything. And
the point was made, it was clearly not a logical point.
But
the conclusion was the same. That's why it was very odd.
I don't know if you were there at the start, Globey, but he was like, is this yours? And I was like, specifically no, but people have attributed it to me erroneously, right? It's from Life is Short, and it says angular resolution video. And then somebody also wrote up a Word document that got attributed to me somehow that also I didn't write. So definitely not mine, but yeah, we have used it.
The Rayleigh's criterion document?
Most of the visuals, dude. He did a 3.5-hour video on angular resolution from which most of this came. And I say that all the time. So no, it's not mine. No.
But okay, great. But like, we didn't look at that and look at it with a critical eye is the problem.
Who's we?
You guys. You posted it on your webpage, right?
Yeah, well, I've watched it many times, dude. I've used it. I've extracted all the images. I've, put it through other stuff. I've used it in many presentations. Yeah.
Okay. So, then the problem is you haven't critically analyzed it because there was a lot of shady things going on in that document, which I'd be happy to point out for you right now. Because this is honestly the crux of your guys' entire argument over the, however long, is we see the same shape that the Earth is, that the globe contorts to be or proposes to be because our eyes just see that way. And it's based on the Rayleigh's criterion. And that's where it all starts, right there. Right? But if that's false, if that's broken, if that's incorrect, then your whole basis of everything else is incorrect.
Yo, I've got a video of that guy right there talking, changing the horizon from a physical geometric horizon at one point.
Yeah, Alan, this is what this guy does.
I'm in the middle of talking, bro.
Yeah, you're just gaslighting is what you're doing.
I'm not. I have
if you want to talk about that, you dress up as a chicken and measure and fold toilet paper to the moon. We could do that too, Nathan.
Get muted by someone?
Yeah, hold on, lads. Hold on. Let's not talk over.
Nathan's just a gaslighter, Alan. That's all he does.
He was asking Shane a question. You go on to start talking about Globey or whatever without saying anything relevant to what he said, then it's just disruptive and not adding anything.
Oh, sorry, Alan. I didn't know.
You're good.
He didn't know. Yeah, that's all he does on TikTok is he steamrolls every flat earther's lives.
I'm hanging out with Free. I didn't hear what you were crying about at the moment. Go ahead, ask your stupid question.
Yeah, okay. Yeah, you'll find out soon enough. He rolls in.
Wanted to go over the Rayleigh's criterion.
Yeah, I was. I can show my screen if you make me big. That'd be helpful.
Sure.
Yeah. All right. So what do we got? So we got the Rayleigh's criterion, right? So we're going to use this formula. This is what you're using. Now, this guy, whoever you took this from, this is your website here. Comes up with some interesting numbers. Very interesting numbers. So first off, he doesn't calculate for theta. He doesn't calculate for theta. I know he has a number here of 0.0216. He doesn't calculate for that. He backs his way into it. And we know that because the angular resolution of the human eye is 0.02 degrees. It's one arc. Sorry, it's on 1 arc minute, right? It's 0.02 degrees or 0.0003 radians. So it's 0.02 degrees. But what did he use in his formula for that? He used 0.02176062. That's 8 significant figures. Now, why did he use a number with 8 significant figures? And where did he get that from? First question. That's the angular resolution of the eye that you guys put into the formula for the Rayleigh's criterion.
You're asking why it's 0.02 or whatever?
Why is it 8 significant figures, and why is it so specific? Where did it come from? He never says where it comes from. He just pulls it out of thin air. Why didn't you use 0.02 as the science says it is? It's a very specific number, isn't it?
Science doesn't say anything. Science doesn't have a mouth, vocal cords, doesn't speak English or Russian. It's just a method of determining cause and effect. So
awesome. So where does this number come from?
Let's say it's wrong. Go back with 0.02 to come out.
Okay, so well, this is the point though. So yeah, so it's a very cherry picked number, 8 significant digits, because what he actually did is he started with needing to get to this number.
Let's say it's wrong. What's the right one?
We are. Here you go. 0.02 is the right number.
That's what he used.
Wow, this guy. You're really peak scientific mind there, Nathan. No, he used 0.02176062. And if you don't see a problem with using that to back into your number, then I don't know what to tell you. Because he took...
I mean, it is weird. It's interesting, but let's assume it's wrong. Let's take that.
Because this is what he did. He needed this number.
Right. Let's compare the two and see if there's what the difference is. Like, where's the issue here?
Because he needed this number. What he did was he needed to solve for this triangle to get the 3 miles to get the radius of Earth to match. He needed half of this angle. So he took half of this angle and said, I need that half. How do I get that half? Well, I'll put the half here and I'll just cherry pick 666 nanometers of the wavelength of light. I'll just pick red for no apparent reason other than I'm going to claim it's because it's minimal refraction. Okay, whatever. He cherry picks that number exactly. And then he cherry picks, he calculates the D out of this. So he started with his answer. He put that in and then he's calculated for D, which is the diameter of your eye. And he got 2.155, another oddly specific number for a diameter of eye. So he calculated out exactly what he wanted by backing his way into it using his conclusion. He needed this to get to the radius of the Earth. And showing you that he's cherry picking all this is whatever. This doesn't even mean anything. Like, just because this angle, it matches that angle of the Rayleigh criterion and you can get R out of it, means nothing.
I really wish I knew you were talking about.
This argument means nothing. It doesn't prove anything, and
what it proves, Nathan, is that the math.
I was still in the middle of talking, bro.
You're just gaslighting again.
No, I'm not.
Yeah, go ahead. Continue your gaslighting.
Proving globe religion, but cool story, bro.
I'd like to ask a question in a minute. I'll wait though.
So yeah, if you do the math, but use the average wavelength of light and then the average pupil diameter.
Can you go back to the image real quick of where he had that 8-figure number real quick?
Yeah, and then just do all the same math. You end up with 13,000 as your radius. It's meaningless.
Right, so 0.021 in the trailing after that doesn't really matter. You can use 55726, you can use 706 through there. The third decimal place doesn't change it that much. Is that your argument, dude? First of all, and like no. Even if you do it out, right, and even if you remove the cherry pick 666 wavelength of light and you remove the diameter of the pupil, you can still solve for that, getting just the angular resolution limit, right? You can still solve for 1 arc minute or 0.21 degrees by just the distance to the horizon and the radius from the other way. So that's why D equals the tangent, D equals D over the tangent of theta would still work with that. Not to mention that you can derive it using other optics, and you can use like bigger telescopes with different wavelength combination. There are literally infinite tuples of wavelength and diameter that would satisfy it, and just as many that wouldn't. And
no, there aren't.
And of course there are, and the ones that wouldn't, you can use to like falsify it would just mean that the geometric horizon would have to be larger. Namely, like for say the black swan observation, if it's longer than the geometric horizon at 1.22 times the square root of the observer sight in feet, then of course the refraction would increase the radius so that it would make it observable, right? That's how that would work.
So you said a few things wrong there. He didn't solve for the 0.021. I just told you that. And you saw that in your own math. He started with that.
Wait. Sorry. Can you go back to that real quick? I was trying to read the full sentence. It gets cut off because it looked like it said where he derived it. No, on the other page.
I don't know what other page.
It was the one you had up before that had like the image
the picture.
attached to. Yeah. Because it looked like it said where it was about to be derived from. It said it was about.
I don't think I showed the picture.
Yeah, it said it inverted the height or something like that.
I don't know what you're talking about.
Yeah, it was the first one you were showing when you were like, right here is the 8-figure number.
Yeah, that was this, the 8-figure number. It was words. It wasn't a figure.
No, hold on, but now this is a different page though. Oh wait,
it's not. Is that what you're talking about?
No, go up a little bit. There, right there. Go to turn. This was inverted as the height information. Turn a little bit. Information loss across the same angle. Here, the red horizon gain for the 6-foot observer across is 0.
He says it in the first sentence. That's what you're looking for. The angular resolution limit of the human eye is approximately between 0.02 and 0.03. And then he just says the angle at 0.0217062 degrees and an assumed light wavelength of 666 was used to derive the radius of Earth. So he just cherry picked a number between 0.02 and 0.03.
Oh, gotcha. Okay.
And not only just cherry picked a number, it's too specific to be cherry picked. So he backed his way into it. He calculated that number out because that's the number he needed.
Well, it works out when you do, 1.22 times the 666 over 1.22. It's like 0.0216 in degrees, right?
Yeah, you're not. I don't think you're getting the point. Okay.
No,
He's cherry picking numbers to get to a conclusion.
Right, but did you hear how Shane was saying you could use different numbers and get the same thing? So it's not necessarily cherry picking, especially when it's based off of the average wavelength.
It's not the average. It's 666. He randomly picked a red wavelength number, 666. It's not the average.
Isn't the average?
This is 666 right here.
500 and 600.
Yeah. No. The average is like 450 or something. 550.
We didn't pick the middle. We picked red orange for the most resistant to refraction at the observer height. That was the reasoning that he put.
Okay. Do we see in just red, or would it be more honest to take an average? Because we see the entire wavelength of light. We don't see just 666, right?
Well, you wouldn't see one wavelength anyway. So what wavelength would you pick to simulate all of them at once, do you think? This actually just simulates a snapshot in time, right? All these
you would
things,
pick 500.
All these circumstances change by the second, right? The atmospheric opacity, things change, the humidity changes, the temperature changes. So what we're emulating with the math is a snapshot in an instant. So at best, is an approximation, right? So when we use 666 or red or orange, you can easily do other combinations, right, that will lead to a different radius, but you can also do different ones that'll lead to the same radius. You can do optics for like thermal, for high imaging telescopes. You can do nano. You can do, some of the higher optic telescopes have the same angular resolution limit with different wavelength and diameter. That's what radiance criterion is mostly used for, right? Is high degree optics. Sorry, dude.
Yeah, that's kind of the point, though. You can put other things in and get other answers and other radius values, right? It's meaningless. You just found the right combination to get you the number you wanted to show everybody and go, look, I came up with the radius of Earth. That's great. It's great. You found the one combination that works, or a combination that works to get you the radius.
This argument is meaningless and going nowhere. Is this the best the Glover's got in 2025, guys?
Well, it started. It started
Nathan, when
off,
you want to contribute, let us know.
Yeah, it started off fairly strong, but there's other ways you can derive it, so it's not really.
Okay. So then part two, we assume everything's right, and it's not, but assume everything's right. How does getting this angle, the 0.0216, and calculating R out of that, how does that equate to we can only see to that radius, 3969? that's the limit of our vision. How does that equate to that?
What do you mean?
So you use Rayleigh's criterion to solve for this angle. You got 2.0216 degrees. How does that mean, how does putting this number into this equation and solving for the radius of Earth mean that's the limit of our vision?
With this triangle right here, let's see. Right?
Yeah.
That's
that's measuring from the center of Earth. I don't even get that.
Well, that's using an arc segment for a circle of approximation, right? So you use the same distance to the horizon over there when you get the same approximation of the radius of your vision, right? So
okay, great. But how does that mean that's the limit of our vision?
What do you mean? This is what we're mathematically deriving from the formula over here.
You just solved the triangle. You said that I have an angle and I have a distance along the surface of 3 miles. And so you solved for the R. How does that tell us that's the limit of our vision? Because that's your claim. All you did was solve a triangle.
Well, yeah, and then we use that triangle to approximate your limit, right? On a flat plane, seeing a spherical limit around you.
I mean, those certainly are words, Shane, but I don't, doesn't answer the question.
The comparison, right, is distance to the horizon on a sphere of a specific rate of curvature and distance to the horizon on a flat plane using the angular resolution limit of the human eye. That's the comparison. So when you can use R equals D over the tangent of theta with that theta being, again, 0.021 degrees, then that's what gives you 3959 as the main radius of the limit of your vision.
That gives you the radius of Earth. That doesn't give you anything, has anything to do with the radius of your vision.
Well, you can say that, right?
It's in your own picture. I mean, it's in your own picture. I can say it, but it's in your own picture.
It's a circle with an arc segment. That doesn't have to be the Earth. That's what we're saying. Like what it would represent, how far you could see, there would be an equivalence there based on the calculation just using triangles.
Right.
So this circle's your eyeball?
Well, you're getting a circumference, right? That's what we're measuring. That's what we're deducing of a circle. And you're saying that circle of a circumference is the Earth beneath your feet. We're saying, well, no, that's the limit of the whatever you're seeing, say each and every side, all over you.
I'm sorry, say that again. I missed that.
It's just the application of the circle, right? You're saying that that's the circle is the circumference of physical Earth beneath your feet. But we're saying that's the circumference of the limit of your celestial vision. That's how far you can see. Right, that's how far.
But you understand, you're just saying that, right? You haven't equated this picture to your eyesight.
What do you mean? We went through
it's
the
literally
first,
derived from the resolvability limit.
Oh my god.
Guys, you got an angle of resolution from the Rayleigh's criterion, which tells you what? What does that tell you? What is that theta telling you? Like, what you solve for theta? What is that theta? What is it?
How far something can be apart before it's
Anybody?
unresolvable.
Great. Great. So that's talking about the angle between the two objects. Right?
Mm-hmm. Which has a limit.
Sure.
And we're deriving the limit to the horizon off of the same functionality.
Now you're essentially saying if I was standing here with that same limit of vision, the 0.0216 degrees, that the limit would be 3 miles?
No, we're using the arc segment, right? So we're using the circle.
The arc segment, 3 miles.
So if you look over to the right there, right, where the circle is, and how there's a dude on the top, right?
Yeah,
and that dude's looking over, right? Yeah,
is that? That is that.
Yep.
Same thing.
Exactly, right? So that's a circle.
Right. So your dude up here is looking this way.
Yep.
He's not over here looking this way. Right? This is the angle of the limit of vision right here. That's the 0.0216 times 2 theta. What does this angle have to do with him over here looking over here?
that helps compute the distance to which things become unresolvable and thus compute the distance to the observable horizon, or in this case, the visual limit where the sky meets the ground, right? That's why it's comparable to the geometric horizon. That's what.
But it doesn't make things curve. It's just telling you that the angle between two objects before they're unresolvable. You solved for something and then just said, I'm going to use that thing and say it means something else.
No, we're using the angular resolution limit to determine the distance to the horizon, right? And we noticed the similarity with the geometric distance to the horizon using Pythagorean theorem from the last dude, right? Went all through that. That's the geometric comparison to this optical limit. We're using the distance to the horizon as the main factor. And then we're using the angular resolution limit in that r equals d over the tangent of theta formula.
Those aren't
the
equivalent.
radius of the circle.
You can't just say they're equivalent. Those aren't equivalent. What you do with the Rayleigh's criterion is when you solve for theta, you get your maximum angular resolution. And then you can solve for a distance using that theta. You can give a distance and then solve for how the maximum distance an observer would have to be to see that. So you can take the 0.0216, put it in here, put like 10 miles in here, and then you can say, all right, given that 10 miles based on my angular resolution of my eye, I would only be able to resolve two objects if they were, 6 feet apart from each other. If they're any closer than that, they'll look like one object to me, or at least they'll start blending together. That's what this is doing. That's what you use theta for. You don't randomly plug it into an arc length of a circle and claim that means something about the limit of your vision, especially using cherry-picked numbers as we went over in the first place. Because again, you can change this value to anything, like you said, and then you can change, observer height and all that, and the wavelength of light, and get a million different answers. Why are those not valid?
They're all valid, dude. You can choose infinite tuples. You can use Rayleigh's criterion to apply to anything you want. You can use it in telescopes. You can arbitrarily start doing dumb shit with it too.
All right, so I used the average wavelength of light and the average diameter of your pupil, and I got 12,500 miles as the radius. So how does that equate to what you're doing here?
We've kind of been down this road before.
Over and over and over and over again.
So yeah, if we could do like a final thoughts or whatever globe, and then or Shane's already kind of reiterated, so if you just want to like end on this, like get your final thought out so we can move on to some other guests or whatever. We've been trigging hella hard and Shane's got to go to work tomorrow.
That's fine. I guess final thoughts is stop saying that our vision is limited by the Rayleigh's criterion. It has nothing to do with the subject you're using it for. The numbers were cherry picked, as I already proved to you. These numbers were backed into to get you the answer he wanted you to see. And you should look through this with a little bit more of a critical eye. And I guess that's it. I mean,
I missed the beginning of it, but was that an argument about globe people disagreeing about the radius?
No. Oh, maybe before I was here.
Well, Globy, regardless, dude, you've been respectful, and I thank you for being chill, because honestly, our experience has not been terrific. You're probably the most respectful Glober so far. So welcome to come back anytime.
Absolutely.
When has our interaction not been good?
No, we're not saying you. We're saying just like with other people. We're saying you've always been mad cordial, so we're just saying respect.
Right. I'm a match energy guy, so when someone like Nathan comes in here, I'll fucking match his energy because he's.
Yep. No worries.
I'll reserve.
No worries, lad.
I'll reserve a comment. I guess I'll end on before I get out of here. I'm sure your guys are close with Nathan, or I don't know if you are or not, but he will destroy your live here on TikTok. Take my word for it or don't, but he will absolutely come in here, steamroll your live, kick every Glober out. If you mod him, I don't know if he's a mod here or not, but he will kick every Glober out and mute them repeatedly, and he'll ruin your entire live. So
he's not here.
Hey, Globy.
That's fine. He knows what he does, and everyone else knows what he does.
Well, that's all good. He's not here though, so let's not talk about him. But I appreciate the concern though. But yeah, what's up, JT?
I was going to ask Globy if he didn't have to run off a couple questions or give like my feedback or context on this whole thing.
I mean, I don't have to run off. He sounded like he was done with me.
Okay, my name's JT. I go by Run Boston Bear. I'm just a, chill dude. So the energy I bring is not, attacking in any way. What I see Shane having done here is backwards derive or undo the deception. If the globe is a deception, I know that's triggering for people that are like globers, but if we really do have a limit to our vision, and we do live on a stationary topographical plane Earth, and the stars are apparent, like if the sun and the moon and the stars are in apparent locations to each observer, then he's basically like, I figured out with math how they came up with the globe belief. And I'm not saying it's a religion or it's a trick. They may have believed it to be absolutely true because they saw boats going over the horizons, etc. So that's what I think Shane's getting down to is.
Okay. I mean, I can address that. So here. So it might be best addressed in this picture, which Alan put up the other day. So it doesn't even make sense when you're talking distances, right? If you're going to claim this is the vision, the limits of our vision, right? That goes all the way around. It's an arc, right? So if this is the radius of Earth, I guess I should show you this one. This is the radius of Earth. Then that's the radius of Earth, or the same radius anyway, right? But now you're saying the limit would be out here, not at the 3 mile horizon.
That's a very poor construction visually for sure. That's thrown together in Canva.
Okay, but I mean, this is how you're representing how to find the GP of a star, right?
Yeah.
And I will point out that, Alan, I mean, I did point out that you got this math wrong the other day, and it seems you fixed it. So I don't know if you wanted to discuss that, but you did use 60 here as your hypotenuse, 60 degrees, 60 degrees. And when I pointed that out in your comments, you kind of told me I was wrong. It kind of made me feel stupid. I got upset. But it looks like you fixed it over here. You put 3959 and 3959.
Yeah, it's probably not bad too, man.
Yeah, so that was Shane's bad, but it is fixed now.
We can blame Shane.
I appreciate you pointing it out.
I pulled it from my Globebusters thing, which I had
Shane also told me I was wrong.
Well, no, because if you use 3959, you can always deduce like that. You can approximate that adjacent, right? You can just get, even if you use just the unit circle, right, which is why I use 60 degrees. So if you use cosine of 60 degrees, it always yields 1/2. So that's why you get 1/2 times 3959 would be that, right? And you can also get other ways using right angle and alt angle approximation.
Right,
but
I mean, you made the mistake of distance to star being 60 degrees. That was a little.
Well, no.
boo-boo.
No, yeah, I put it there because I was trying to illustrate it, and it took it as the hypotenuse. So that's my bad.
A little boo-boo, but the point is, it still holds. If you're claiming this is the limit of our vision, why is the limit of our vision start at 3 miles, not 3959?
You're observing different planes.
What do you mean 3 miles?
Well, that's when things start to quote unquote go over the horizon, right?
Well, we're not talking about ground-based observations. This is like to the celestial heavens. We're talking about stars. We're talking about the distance to the stars that we use in our equidistant web around us.
But this is also a reason you guys use for things going over the horizon, right?
Well, we related it with the math, right? This is the other application.
Right. So if you're going to use this as a reason why things start to disappear as they go over the horizon or get too far away, then that has to equate to that, right? And this is telling me that the limit is 3959, which is, that math is contrived anyway, but how does it equate to 3 miles? How does that relate to the 3 miles, not 3959, when things start to disappear like a ship?
Well, again, we're using distance to the horizon for the surface level observations for a 6-foot observer. And then we're deriving the radius of that circle with which we're using an arc of it, right? And then we're reapplying that circle to a radius of our vision. So in this depiction, we're using the circle to depict our hemispherical vision. And that's why we have the equidistant web of 3959 in this specific visual.
Okay. Not really sure what you said, but okay.
No, Shane, will you please repeat that? Because I did understand what you said, and that was very important. So can you please repeat that for everyone to hear again?
So, yeah, 3 miles is the distance to the horizon for a 6-foot observer, right? But we use the R equals D over the tangent of theta to get the 3959 for the equivalent. And that, so of course, we use the circle to get that. We use an arc segment of a circle to get that. And then we're applying that circle differently. You apply it to the ground beneath your feet. We applied it to the radius of our vision. In this case, it's depicted visually as a hemisphere around the observer. So that's why the 3959 is the difference to the star.
Yeah, I mean, you just kind of went over exactly how you calculated the 3959, but I'm still not sure how that applies to an observer watching a boat go out into the distance. Why is the limit not at 3959? Why is it start at 3 miles?
Ground, you'll be able to see, like, I don't know, an ant or something like that. And
Yeah,
then
the
when
angle
you're
between the ground and the horizon is smaller than the ground and the sky. So you can see, you see like, over the, like if you were at the equator, you would see Polaris at your horizon. So like that's that's pure sky observation there. So like the difference is you're talking about the sky versus, just like a horizontal observation. So like this is why it relates to a hemisphere and why they have it set at an equidistant web. That's what I was talking about earlier when we were talking about the celestial sphere and the position of stars and how this relates to the latitude longitude system. Because this is all equivalent and this is all how it works. So
I mean, I get what you're saying. It's equivalent. I mean, just saying it's equivalent, and I showed you why it's not equivalent earlier.
With respect, Shane also showed you how it's not cherry picked and it is equivalent.
Wait, he showed me it's not cherry picked. Can you show me that again? I missed that part.
Yeah, he gave several examples of different optics you can use for telescopes and stuff. There's actually an entire spreadsheet. Shane, if you could link that to me, I'll just send it to Globe or whatever. But there is other things you can use, right? So,
if you put in different wavelengths and back your way into the number again, you could sure get different numbers. So I'm not sure how that disproves that he's cherry picking.
Well, you say back. Well, hold on a second. You say back your way into it, but if we're changing the wavelengths and diameters, then we're calculating it and it comes out to be the same or similar, and we're not backing into it. We're just calculating it with different variables, like what you're doing. So we're saying like this, and keep in mind this argument purely is optical. So like, even though you might not acknowledge our position, the equivalence here, we would have to move to a different thing to argue how to determine which interpretation is actually correct, because we're kind of just, kind of reifying each other or, each other's positions essentially.
I mean, that's the argument you guys want to make now, is that we're reifying each other's arguments. That's new. That's what you guys are trying to do now, is say that it doesn't matter, there's an equivalence.
So we derive the radius, which can't be proven empirically, of the ground curving with our eyesight, and the convergence rate. This is the direct correlation between convergence rate that we're talking about, right? So it's a fundamental law and perspective that there's foreground, midground, and background, and the midground would be up until the vanishing point. The background, everything, the stars, the mountains way off in the distance, that's all in the background, right?
Great.
That's why we have a visual to the horizon at 3 miles or just under 3 miles with a 6-foot observer, but well beyond that in the background. This is depth perception 101.
Depth perception 101. Okay.
Yeah.
And that limit of vision is created by backing your way into the limit of our vision. Because if you use the angular resolution of your eye and you use the average wavelength of light, you can calculate like 3 miles is about 6 feet of angle between objects. So as long as they're further than 6 feet apart, you'll be able to see two objects, right? If they're if the boat's at the horizon, the boat's at 3 miles, you wouldn't be able to distinguish them between each other because the boat's touching the water.
It's matching the convergence rate. Absolutely.
Yeah, but it's not. So the drop is, how much is the drop over 3 miles?
If you have a 6-foot boat,
67 feet, right?
It should match. And if you have it matches your convergence rate. If you have a 12-foot boat,
67 feet of drop, right?
But
that's what the globe math says. That's how we see boats go over the horizon. It's not matching. You only have 6 feet of angle between the two using Rayleigh's criterion.
Well, actually, at that distance, we'd have 3 foot and 3 foot with a bulge in the middle.
But then why when we zoom in, can we bring them back in though? Like it's clearly an optical.
Alan, that's never been done.
You've never seen someone zoom in and bring a boat back in, bro, when it goes out?
I've seen someone zoom in and bring a boat that can't be seen back in. It's too small to resolve by the eye or the camera. A small boat. You've never, ever, once ever brought a ship that's hidden by the horizon back into view. Ever.
Well, you would never know
This
if
is the
it's...
big boat argument.
Dude. No.
I didn't bring it up. He brought it up. If someone can show me one, I'd love to see it, because all you're going to show me is a small boat that's very small, that can't be resolved by the camera, suddenly appearing as you zoom in. You're not showing me a boat coming back from over the horizon, ever. I can't believe you guys still talk about this like that's a thing.
Because boats don't go over the horizon.
Well, I know you claim that. I know you claim that, right?
Big boats don't.
Respectfully,
That's why it's very laughable to us.
I came on the live, and you guys been talking about this for a while. A whole bunch of apparent stuff happening. You guys step out to the house and see this stuff. Let's talk about 3-4 vectors on a spinning top. How about that? I know Space Audits has something to say. I think I saw in Witsit's, I think the core of the belief. That's when you added a little bit onto there. But it was the wobble in Schooling Globers and Witsit's.
The 4 quad wobbles.
Yeah, I mean, come on, guys. Let's stop arguing these little things and let's talk about the 4 wobbles. That cannot happen, guys. Come on now.
Dude, the Chandler wobble, obliquity of the ecliptic, nutation, and what's the other one? I forget it.
Yeah, what is
just a general wobble?
Can someone show me a ship being brought back from over the horizon? I'd want to see one. I mean, maybe if someone can go find one while other people are talking.
No, man, that's the math. But this is like gyro. What's it called? But yeah, you can't do 4 wobbles. You want to talk about Space Audits? I believe I recognize your voice.
Yo, what's up, man? No, Shane's the wobble lad.
Hey, I'm gonna share the mic. I'm gonna drop out, but I want to close with this. I know that people have gone back and forth and debated this whole flat versus globe thing like crazy, and ultimately we're all looking for the truth. A couple legends that I look up to is Dr. Stephen A. Young and Mark Gober. Neither of them are, uneducated. Stephen A. Young, he wrote the book of Fool's Wisdom. You should check it out. He has a master's in physics and a PhD in nuclear theoretical physics, and he definitely knows we don't live on a globe. And Mark Gober, he graduated from Princeton, magna cum laude, and he wrote the book An End to the Upside Down Cosmos. I'm going to have a stream with them pretty soon. Awesome guys, been emailing them. So yeah, this whole flat versus globe thing's not going away because people want the truth, and I think we've been lied to. But thanks, Globe Face, for being chill. It was nice talking with you.
Absolutely.
Yeah, dude, you got the Elmo wobble over there. Precession of the equinox, nutation, obliquity of the ecliptic, and the Chandler wobble, right? And the depiction on Wikipedia for nutation looks like a psychedelic gyroscopic fan blade or whatever. It's going in so many directions, trying to just do one of those motions that I don't think I've ever seen all 3 of these depicted anywhere.
Okay.
Well, that's it. That's, impossibility of a rotating sphere.
Why is it impossible? Because you showed some pictures. I don't get it.
Well, no, I'm asking for a depiction of it, right? People say it's mathematically possible, but no one's ever shown it.
Okay, so if I show you a computer model of it, will you say you believe it?
Since I brought this up, guys,
I will shut up about it for sure.
It was presupposed off of one axis, and they're all spinning at different rates. So that's kind of impossible. Speeding up and slowing down on one axis, 4 vectors on one little on one ball. That's how can
Hello, everyone.
I can't even think about that. But
I mean, just saying it's impossible is not making it impossible. You understand that, right?
Yo, while you guys are chilling in the background, I got a video up of a boat on the horizon being brought back in from 80 miles. Here we go. I'll move this over so you can see it. Shout out to Mike Ball.
Why is it nighttime?
I don't know. I just work here, bro.
It's going to be a little hard to see, isn't it?
I mean, we'll figure it out. I haven't seen this before, bro. I'm in for a ride just like you.
It says Milwaukee. Doesn't say a boat. It says it's a picture of Milwaukee.
Oh, he's not bringing in a boat. I'm sorry. He's bringing in the entire city. My bad.
Yeah, that's just making the city bigger too, but. Okay.
So 37 feet should be.
I want to see one be a first.
Well,
But a
3,700
city
feet should
that's
be
supposed
hidden.
to be hidden behind ball curve.
Yeah, 3,007 feet of it. So, I don't
Is
know.
it?
Yeah, that's what it says.
That's what it says, but is it?
I mean, dude, do you want to play the is it game or do you just want to go calculate it out? Like I can send you the stuff.
We can go calculate it out. You send me out because Taboo Conspiracy isn't known for his excellent research.
Actually, any time that I've ever seen him get corrected on a video, he actually retracts it. I know I can think of like at least over 5 instances where he retracted things that were wrong. So if you could actually point out why this is wrong, I'll contact him and tell him like it was wrong and he'll take it down.
He never admitted his Mount Canagoo observation was wrong.
Well, that's still a huge point of contention, and I don't think anyone's actually shown that that's wrong.
Really? Okay. So there's the ones with the quote unquote mountains behind Crete. Is one the supposedly you're seeing mountains during a sunset over Crete. Yeah, those are clouds. I can show you they're 100% clouds. They move from left to right as the sun's setting. They're not mountains.
Roby, would you be interested in a celestial theodolite observation? Would that interest you at all? A theodolite observation over Pikes Peak? Could we possibly go over something like that with you? Would you be open to that, sir?
If it's the video Alan posted earlier today or yesterday, I've already watched it.
But can we go over it with you? This theodolite observation?
What are your thoughts?
If you like to, you can go ahead. My thoughts were I downloaded it to take a look at it later. I haven't got a chance to look at it yet.
Oh, you haven't looked at it yet? Well,
I watched the video briefly, but
right here, live. And get your commentary.
Weren't you the one saying not to put people on the spot earlier? Wasn't that you? Wasn't that you saying it's not nice to interrogate people?
No.
And here you are. Maybe we should get your live reaction.
That was me, not her. That was me.
All right, I apologize.
That wasn't
but I'm
me,
sure
sir.
she was thinking the same thing.
But no, I was just wondering.
Oh, right.
I mean, if you would like to go over it.
We can watch it. It says live. If you want to watch it, that's fine. I mean, this observation relies on
comedy, bro. You're comedy.
This observation relies on, I haven't fully absorbed it yet, but, you're also just taking his word for a lot of things. I didn't see anything but numbers written down on a page. So.
I understand that. It is a lot of math. It is a lot of numbers and math written down on a page. So it does take some time to go over and understand and absorb what it is that Professor Mike has put forward here. It does take some time to understand it for sure. But I don't think that it is math that would be above your head in any way.
Well, he also used stellarium for his elevation angles at the top of the mountain. And I'm not sure. I have to look into that. I'm not sure how accurate that is or if that's even possible to remove refraction out of their calculations, because I know he claimed that he did all that. He claimed he removed the refraction out of the stellarium program to show elevation angles without refraction involved. I don't even know if that's possible.
You can just turn it off. It's an option.
You can turn off the atmosphere, but I don't know if that changes the value of the elevation angle.
Yeah, this class performs the refraction computations, and you can just turn it off. There's a class for it. You just switch it off. Apparently.
Okay. Well, I have to look into all that. But yeah, if you want to play it, play it.
But yeah, that would be awesome. So yeah, we'll go over it.
Can I call my 2 cents in on stellarium?
Absolutely. Go ahead.
It's my understanding that refraction is busted in stellarium. Don't work.
What's busted?
Refraction is busted in stellarium. It doesn't work. Like the feature itself don't work.
Okay.
I think it was Mick Toon that told me that, because we were in contention about the observation of the Southern Cross from the Canary Islands, and he brought it to my attention that refraction is busted in it. But it ended up being, so there's other software you can use, like telescope aiming software, It's like that's called like C2A, and you can put in your elevation and your and you can turn atmospheric refraction on and off. So maybe
that part of it definitely has to be looked into.
I wouldn't rely on stellarium. It's kind of a toy.
I certainly would prefer, if he's going to do something like this to test it, to actually take the measurement himself, if he's going to do it. But I don't think he's going to climb to the top of a mountain.
I'm like you. I didn't get a chance to go over it. I just briefly skimmed it. So, but I just think stellarium is not a good tool to be using to where the stars are.
Yeah.
It's because it's a toy, really. It's not like you can't aim a telescope with it. So.
Sorry, it's just the celestial sphere. I've never found a single wrong observation with it, but yeah.
We gotta dial it back a little bit because we're talking about apparent things again, guys.
But we weren't talking about
things.
watching the video. Could we go through possibly the observation again and just walk through and start it? Is that possible to start?
Do we need to watch it? He said he watched it already.
I think everyone here saw it.
No, I just meant walk through it. I'm not sure that everybody is here. Just what we walked through at the beginning. I mean, you may have, but I'm not sure that everybody has.
Yeah, just a quick recap so everyone knows what we're talking about. But also, anyway, the Milwaukee Sky. I was thinking about the Milwaukee thing. Okay, so anyway, we have Pikes Peak here from Colorado at 50.7 kilometers away. And he's going to go over the angles and math involved here. So I'm just going to scroll down. So getting his laddie and longy there to get his distance from his house to get his bearing to the mountain, he goes over and determines that the theta angle here will be 2 degrees and 31 arc minutes based off the height of the mountain here being 2,226 meters and the distance being 50.7 kilometers. So he's got his theta angle there. And what he's going to do is he's going to measure a star being occulted behind this mountain, showing that this is physically there at this location based off of the flat Earth elevation angle. And then in addition to that, he says that, when you have refraction turned off on stellarium and you put an observer at the top of this mountain, that this theta angle stays the same, indicating that that is the true elevation angle to the star. And it's not, the contour of the Earth isn't curved away from you, because basically what will happen is, if that's true, these are going to make separate predictions here for the angle for the observer on the ground versus on the top here. And in addition to that, the refraction, because we're looking through the same optical corridor here, any refraction applied has to be the same. So if this mountain is in its true position and it occults the star, then that's actually where it's at in the sky. So we'll go through here, look at the tech specs, what he used. He used, someone's hot micing a little bit. Thank you, sir. So he used the David White 8300 Theodolite. This is supposed to be like the best Theodolite ever made or whatever. So he gives some tips on the tripod and stuff if you want to get one yourself. Anyway, it goes over the derivation for that angle again to get the 2 degrees and 31 arc minutes. And as he goes through, he shows the refraction coefficient that turns all observations into, it basically turns the difference into refraction. That's why I personally don't argue terrestrial observations, because the refraction coefficient will make up the difference every time to turn it into a planar observation. And if the two positions are, I believe it's a plane versus I believe it looks like a plane due to refraction, then those positions are equivalent. So it's hard to, determine which is the correct position there. So that's why this star occultation is super important, because it's going to show that the exact position of that mountain in reality is at 2 degrees and 31 arc minutes, because it's going to physically block a star that's supposed to be in a different location based on the globe here. So as we scroll down, we can see the globe prediction.
Okay, I have a question.
Yep. 1 second. Here's pictures of the star being occulted. And then let me show the globe prediction, and then we'll do questions. Yep, here we go. So the globe predicts that this angle would be 2 degrees and 19 arc minutes, and they actually use refraction to make up the difference there. And then based off of the star there, if that's occulting it, it's going to be 2 degrees and 41 arc minutes. So it's going to be higher than what is actually measured there. And it's revealed that its true location is at 2 degrees and 31 arc minutes. All right, go ahead, sir.
So first off, I like the idea. I like where he's going with this. But my first question to you guys on the panel is he taking into account curved visual space and the fact that we have limits to our vision that make us see everything dropping in the sky like a globe? Because
yes.
If his observation is matching what you would expect on a flat Earth, then you're not seeing what you would expect on the globe. Therefore, it's not globe vision, as I call it. So it seems a little hypocritical.
No. So what we're looking at here is you guys would say that, due to refraction, the star is actually in a different spot. And like normally you could get away with that, but the purpose of this is to show the difference. Now, when you say, did he account for curved visual space? Well, yes, by assuming that equidistant web for the location of the star in the first place, this is in relation to where it would be in your field of vision.
But I don't think so, because if it was, then it would have matched the globe prediction.
Ooh, so here's the thing. The globe prediction actually only comes out of adding that refraction coefficient that was mentioned earlier. There is no globe prediction. And if that refraction coefficient were true, we would have two different angles produced here. So
we're not talking about refraction. I don't think you're getting the point.
No, I'm precisely getting it, because you're saying that, the globe prediction is XYZ, but what you're not realizing is that the globe prediction is supplemented by refraction. And when you turn off the refraction coefficient in stellarium, it's just showing you the equivalent, like that it's literally the same planar observations that he calculated. That was the whole purpose of him going through this at the beginning here, because this is the flat Earth prediction. This matches what stellarium shows with no refraction. And when the star occults this, in reality, it shows that is the physical location of it, and it's not being refracted up.
But so what you're saying is what he's looking at here is not matching what we've talked about for the first 2 hours of this show. Well, not 2 hours, but you know what I mean. Like it should have matched the globe prediction without the refraction, or with the refraction. It should have matched it.
The globe prediction is just an elevation angle to the star. The supplemental correction for where it's at comes from taking zenith measurements and assuming either ellipsoid geometry or gravitational undulations.
Okay. So you put he put refraction in there, I'm guessing, right? That's what you're saying, and that corrected for the globe observation to make it match the flat observation. Is that what you're saying?
I'm saying that the globe assertion of that refraction coefficient is false, because that mountain is physically there in that location to occult that star. That's why it works. That's why the angle. That's why the
refraction exists, though, right? I mean, you agree with that, right?
Absolutely, but to the magnitude that it's being applied to make the globe model work, it's clearly just a supplement. It's literally the missing difference in all observations to make it a globe. So without that, we're looking at a literal planar observation, and then for it to be occulted by the mountain and then still share the same relationship with the angle when you put an observer at the top would completely falsify the globe.
I think it would falsify your theory at the beginning of this chat. But he didn't go up to the mountain, right? He's using stellarium.
Yes. As far as I know, yes.
Okay. Yep. So I don't think I'd believe that that's an accurate observation unless that was being measured both locations. But
that's a fair point of contention, I suppose. I would like to see him be able to go up there and do that as well, but it might not be.
I like where he's going with it, but I think it's a bit hypocritical.
I'm telling you guys, we got you guys with the wobble thing.
So I just wanted to.
Oh my God, with the wobble thing.
I just wanted to reiterate though, like, is your position that stellarium is incorrect then? Because he was using it to verify, and I've heard most people on the globe say that it's correct and can be used. And Indio was just saying that the refraction coefficient may be off, but we're dealing with the refraction turned off. So the globe should suddenly the globe is matching the flat Earth prediction with optics with using the same radius. You know what I'm saying?
The globe is matching the flat Earth observation.
When you turn refraction off specifically, there was another part to that sentence that is important.
Oh yeah, when you turn refraction off, yes. But again, that doesn't make sense, because it should be matching the globe observation.
Yeah, right. But in reality, though, the thing is, though, like this mountain matches that flat Earth prediction and occults it at that
But
same
there is no
angle.
flat Earth prediction. Don't you understand? You just said there's no flat Earth prediction. The flat Earth prediction is the globe prediction. This was your whole argument for the last 2 weeks.
That's not what my premise has been. What we're talking about with the optics and the positions of the stars, we're saying you see this, and you guys are saying that when you apply corrections, that the star is actually in a different position. And this falsifies this because this angle here is represented by a physical object that is causing the obstruction. This doesn't exist. This geometry to create this doesn't exist on a globe. So your argument would have to be now that stellarium is wrong.
The mountain refraction applies to everything.
It will,
right? If you're looking at the peak of that mountain, it certainly would be refracting, right?
And the coefficient used to describe it is wrong because it would predict a different angle for that position of the star. We can see the other prediction.
What about the height of the mountain? That's what I'm saying. Did he take that into account for the height of the mountain?
It's part of how he got the angle. What do you mean?
What he pointed the theodolite at the peak of the mountain. There was like a building up there, right? And he pointed it at some sort of building at the top of the mountain, and that's the peak of fire.
Well, he didn't point it at the building, but he was saying that you can see the building from the ground there because it's flat on top.
Oh, I thought that's where he took his measurement. All right, so what did he take his measurement to the peak of the mountain?
No, he was 50 miles, 50.7 kilometers away in his sunroom.
Okay, but so how did he measure his angle to the mountain? He had to have lined it up with something, right? He lined it up with the visible peak.
Yeah, Theodolite. Oh, yes. I'm sorry. Yes. You're right.
That's what I'm saying.
That's at the top of the mountain. That's square center at the very center at the top of Pikes Peak.
Right. And when he calculated that angle, did he correct for refraction for that angle? Or did he just do it with the star?
So did it for both, if I remember correctly. And then the point of contention would have been like, if this refraction calculation is true, then this mountain won't be here to physically occult this star. And the fact that it shows that the refraction coefficient that's used is unjustified to claim that it's a globe because this mountain is physically there. Like the purpose of this is to differentiate between the two because the globe only exists through mathematical corrections to positions of the stars and assumptions about the ground. And this shows that those assumptions are false and the corrections are the only thing that supplement the belief in the globe. Otherwise, the star would be there would be a different angle.
Well, like I said, you got to look through this. I think a major flaw is relying on stellarium for unrefracted elevation angles from the peak of a mountain. It's a very specific location.
Okay, so so real quick though, the globe predicts 2 degrees 17 arc minutes, and the one for refraction for the star on the globe would be 231. Now, when you put the theodolite to the star to make the measurement at the tip of the mountain, right? They all have to agree with the same refraction coefficient. And if they don't, then that means the refraction coefficient that you're using is wrong. So the raw star measurement of 2 degrees and 31 arc minutes is where it's actually at. The predicted globe refracted would be 2.46.
Okay.
So do we know the observer height? Because I've measured Pikes Peak before with the theodolite.
The observer height? Yeah, he's like, let's just say 6 feet tall.
6 feet from.
He might be on something.
No. So it did Denver, right? Denver, Colorado is about that far from Pikes Peak, right? And that's a mile-high city. So that observer height is kind of relevant to Pikes Peak's elevation, right, guys? I mean, you guys are the math guys. You know.
Well, yeah, you need.
He used his GPS location to get the mean sea level. We're good.
Yeah. So off of mean sea level, what is the observer height on this theodolite measurement to Pikes Peak? Because that's very, very, very relevant.
I don't remember him saying that.
So a mile high, like a mile is 5,280 feet, right? right, gentlemen? So what is the observer height going to Pikes Peak, which is what, 14,000 and some odd feet, right? Because that will be very relevant to the elevation angle that he's measuring.
What he needs is the elevation of Pikes Peak relative to his elevation to get the angle. Now I don't know if he did that, but that's what he needs to do.
Well,
unfortunately, he did this to his house.
So we can read how he did it right here. So
well, the problem I have, Alan, with this is that, and I don't blame him, but if he gives us actual coordinates so we can, check the math, like we're gonna have his house because he did it from the sunroom. And that's probably not a good idea.
And also, real quick.
That's okay.
Real quick.
But he can give his elevation. I mean, he doesn't have to give his location. He can just give his elevation, right, guys?
Well, we need the distance, right? So.
Yeah, but that's fine. You give the distance and the elevation of your observer height, because you have to in order to get these measurements. You absolutely have to.
Yeah, I agree.
2,074 meters above sea level is what it says right here.
2,074. Okay, let me check that.
So anyway, Stellarium also accounts for your elevation or height when you enter your lat long. It has the topographical map built into it. But yeah, someone's mic's going off a little bit in the background.
It's like
typically these star software programs, they use what's called the astronomical horizon for your level. So like when they tell you like a star is 2 degrees above the horizon, they're using the astronomical horizon, which is basically your eye level. They're not using like what they would call, I think they call it the rational horizon or something stupid like that. Astronomy's got their own terminology, like their terms of art.
All right, but yeah, we've been going for 2 hours now, so we're probably going to wrap up in like the next 10 or so. If you want to figure out your thing,
we got to get this. We gotta get this wobble thing down, man. The sun was going too fast. The moon was going too fast. The stars were going too fast. And I forget what the fourth one is, honestly. But that's enough already. They can't get it down on a gyroscope. That's impossible.
It's a rough one. I would like to see it modeled.
Yeah.
Or whatever.
So it's like either everything's moving individually in the sky just based off what we observe, or you can't make it work any other way. Like, we could try, but try as you might,
You know how long those wobbles are?
Wobble like Elmo can. I think that's probably the best meme for that. Like, show us the wobble.
Did you know what the precession of those wobbles are on Earth?
Yeah, it's like thousands of years or whatever.
It's 24,000 years for the regular precession.
Yeah. And then one's 18.6, but that's still speeding up and slowing down on one
over 24,000 years. What do you expect to see in the sky because of that? No, it does matter.
Well, listen, it's still, it doesn't matter how long the scale is, like at the time, right? It's still all tied to the same axis, which is super weird. Like that's why we're calling it into question, because it's just.
And we tried with the gyroscope, but that's not even like close to like a spinning top. Like, how do you even make it work?
You're right, guys. They they made up all these impossible wobbles just so you guys could figure it out one day on TikTok. It's crazy. It's crazy talk.
I mean, that's not a good argument.
Like other astronomers have noticed that the problem with the wobble, the precession of the equinox, doesn't apply to planets. And that it only applies to stars for some reason.
Yeah, well, a good argument is not saying it doesn't work because it doesn't work.
Yo, for real, India? Who said that?
Yeah. I can actually give you published peer-reviewed papers from astronomers that have pointed this out. They've known about it for hundreds of years. It's a problem.
Yeah, please, dude, that would be great. That's awesome.
So whose data is this that took this measurement? Because my measurements from 56 miles away, I was 5,550 feet. So this guy was 1,300 feet above me, from closer to that peak. So I'm wondering exactly where he was. I don't expect him to give
50,
us where he
50 kilometers, but not 50 miles.
So what did that equal? Like 30 miles? 50 kilometers is what? 30 miles?
31 miles, someone saying in the chat. It's 50.7 if you want to get precise, but
yeah, it's 31.5.
Feel the scrambling on a vibrational level.
So he was
per square mile.
So he was 31 miles, and he was 6,800 feet. I was 56 miles, and I was 5,500 feet. So he's 1,300 feet above me, and he's closer to that. That's a lot of difference. But let me see if that math checks out. 6,800 feet. 800.
I'm telling you, watching this after I just said the wobble thing is like, you guys are done. You guys are done.
It's such an odd thing to harp on. I can show you a rocket video from space of a private citizen, which I showed some of you guys the other day, Alan.
Yeah, I don't contend that you can send a rocket up and see things. Like, that's not.
What kind of camera did he have on it?
A GoPro retrofitted with an M10 rectilinear lens.
Like, optics doesn't just magically go away.
Doesn't matter.
I love your show, Space Audits.
Wait, I want to hear what the name of the camera is. And I want to see the video.
So no lens is rectilinear when it's used outside its specification.
Excuse me, say that again?
Yeah, no lens is rectilinear or stays rectilinear when it's used outside its specification.
Well, so what's its specification?
Well, it sure as hell wasn't designed for near vacuum with negative 50 degrees centigrade fucking temperature.
So the air pressure around it is now affecting.
Yeah, it does.
Affecting the rectilinear's lens and making flat Earth a globe.
No, I could send you papers. It's called Design Steps for Temperature Insensitive.
Okay. Yeah, you send me a picture.
No, I'm going to send you a paper.
That's what I just said. Send me a paper.
When they design these things for high altitude aerial photography, they have to design them to compensate for the temperature and the increased because the refraction of the lens is a relative value. So it's
increasing with altitude now.
No, yeah, exactly. So
interesting. I thought refraction decreased because air density was decreasing, but I guess it's increasing now from space.
No. Listen closer. It's the relative value.
Mm-hmm. The
relative is a relative value. So you have the air has a refractive value. The lens has a refractive value. When you go up in altitude, the refractive index of the air goes down. So now the relative value of between the lens and what's outside the lens increases. So when the light goes through the lens, it does not preserve the same geometry that it would have when it would have been on the ground.
Yep. You send me that paper, Indy.
And it projects the image, which has what's called Petzval curvature.
Yeah.
So it creates like a meniscus image on the sensor because now it's outside its design spec.
Right.
Yep. I forgot we were spinning.
I'll read it to you. I'll just read
What's the name of it? I'll look it up right now.
Yeah. Hold on. Let's get it real quick. Hold on.
I mean, Alan's going to drop off in a few minutes, but I want to read this. This sounds amazing. So it's taking a flat Earth and distorting it because the refraction of the lens.
So a straw man. That's the best you can do is to make a straw man.
I'm trying to steel man your argument right now.
No, you're not.
You tell me where I'm wrong.
I said the geometry that you're seeing is not the
correct.
actual geometry. That's right, and it has nothing to do with flat Earth or not. It has to do with the true geometry is not preserved because you changed. So when they designed the lens for one condition, you changed the condition from which it's operated, and now the geometry that it would be in one state is not in the current state. And the name of the paper is Design Steps to Pressure and Temperature.
Hold on, slow down.
Okay.
What is it?
It's called. It's by a guy named Yilmaz, Yilmaz. Is Yilmaz O.L. Design steps to temperature and pressure insensitive optical systems for digital aerial imaging.
Yeah, I kind of
And
said
I can read you right from the paper. The effect of pressure comes when relative refractive indices change due to air pressure. Actually, refractive indices of materials are defined relative to air at a reference temperature and pressure. It is said absolute refractive index, it means that reference air pressure is zero vacuum. Relative and absolute refractive index depend on each other as follows. When they give an equation, this means that when the materials are put in low pressure environment, their relative refractive indices increase since absolute index is constant and the low pressure means low refractive index air. This causes increase in refractive power of the system and therefore causes defocus. And if you go defocus, it has this defined is pencil curvature, which creates like a meniscus type surface in the image.
Okay. Do you mind saying that name a little bit slower for the third time?
Design
I'm trying
steps.
to type it, so you got to help me out here.
Okay. Design
steps, yeah.
To temperature and pressure. Insensitive.
Oh, can you
optical
mute the typing, brother?
I can't. I'm typing as he's talking.
Where are you at?
That's me.
Are you at optical systems?
Pressure insensitive.
Optical systems for digital aerial imaging. And it goes through all the factors that you have to design. Typically what they'll do is they will design it for high altitude, and what they'll do is they'll make a hermetically sealed interior, right? So that like inside the system itself, they still got to deal with like what's outside the lens, but you have the problem of what's inside the lens and what's outside the lens if it's not sealed, right? Because of the temperature. So they seal it so they don't get, because the temperature also changes the dimensions of the lens physically, and it changes the dimensions of the entire optical system physically. And if you're doing high resolution freaking imagery, then that's like, a problem.
Okay, so your claim is that even though we can watch this video from a rectilinear lens and it matches the globe curvature as modeled at every step of the way. Walter Bislin's model.
Yeah, that's trash.
Oh, it's trash. Okay, sorry.
Okay, so tell me when I click on the Theodolite feature and it says it's pointed at eye level, it points at the horizon. Tell me why it does that.
No. I have a Theodolite.
So I can see here and go over all sorts of problems in business model. I'm not just saying it because I don't like this model. I can go through dozens of problems with it where it doesn't work.
I have a Theodolite. It doesn't do that. And even Taylor has one. She knows that doesn't do that too.
Yeah, dude, like we're talking about something.
So check this out. Check this out, guys. Pikes Peak is 4,302 meters, right? It's not 2,074 meters, right, guys? Pikes Peak is more than twice the size that you guys pulled up, right?
Oh boy, is that true?
Make it worse.
Yes, that is a fact. Pikes Peak is 14,115 feet, which is 4,302 meters. It's not 2,074 meters wide like you guys brought up. So what's up with that?
All right, let's double check. What did he say the height of Pikes Peak was in that?
Was it subtracted from his height from the observation?
So he says the visitor center is at 4,300 meters, 57 from me to at 2,074 meters. The tangent of that, 4,300 minus 2,074 divided by 5070, 700.
Yeah, see, he did measure to the visitor center like I thought, which I guess is at the peak. It looks like it's at the top there.
Yeah. Yeah, my bad.
40.
Right.
So he said 4,300 meters, and you're saying 8-inch?
Yeah. So it is 4,302 meters.
Yeah, so we're good.
So what I got with the numbers you gave me is 4 degrees, 39 minutes, and 21 seconds. And his conclusion was half that.
Are you able to send me what you got? Can you take a picture of it and send it to me?
Yeah, I could do that.
Or if you could,
it's 31.5 miles, which was how many kilometers? Right.
50.7 kilometers.
50.7 kilometers. Okay. So let me turn my camera around. I'll have to look at my ugly face.
We love the honesty. Let's keep it up.
Right. So 50.7 kilometers is 31.5 miles. That's what I got, right?
Yep.
And Pikes Peak is 14,115 feet, which is 4,302 meters. So if I'm, and then his observer height was 2,074 meters, is that correct?
Yeah, Globey, I'm gonna mute you for a second while you're typing.
Was it, so the observer height was 2,074 meters? Is that
Yep.
right?
Yep.
Okay. So if we're 6,804, let's just verify that just to make sure I'm not messed up here. So 2,704, 2,000 meters to feet. That would be 6,804 feet. Okay, now we're rocking here. So 6,804 feet, and the distance is 31.5 miles. Excuse my sloppy handwriting. 14,115 to Pikes Peak. That's just now we have a triangle, right, guys? So I'll just subtract my height. 14,115 minus 6,804. So 7,311 divided by 31.5 in feet. 31.5 times 5280.
Like birds love to fly, they think it's fun to fly. That's what we're doing, but we gotta come down to the ground level and realize that these wobbles, you can't.
I've been wondering about these wobbles. They're crazy, aren't they?
Yeah, man. They're
Wobbling
crazy.
up busy actually right now.
Elevation angle is 2.5. One seven, we'll call it.
While he's doing that, I'll say, unless I'm doing something wrong, I went into Stellarium and put in the latitude and longitude for Pikes Peak, and it's telling me the elevation is 1636. So
1636.
I can manually change it. That's not right. Still, it didn't move. I put in Denver, Colorado, and it didn't change when I put in the exact location for Pikes Peak.
I went to Pikes
So
Peak.
I'm not sure this thing is.
Okay, so I got on a
well, there's a
flat
lot of places named Pikes Peak, so I mean,
if the Earth is flat, that elevation angle would be 2 degrees 31 minutes. 1 arc second.
Yep.
From his location.
What he calculated out.
Okay, so where's his measurement at? Let's see the measurement. Or does he not have that information or a video?
Oh, you mean like a video of
show
him?
it.
Yeah,
He
you
didn't
mean
show
like you mean like a video of him doing the measurement? No.
Okay,
It's kind of a trust me, bro kind of thing.
Well,
in his presentation, he said that he tried to take a picture to the Theodolite, but it wouldn't come out.
Yeah, he
Okay,
does give us a picture of his telescope though.
If I'm not mistaken, I did this and I got it on video, right? And I did the flat Earth, the flat Earth prediction, and then I got my globe Earth prediction, and then I showed the video. I could probably go and look for it and find it. I do this all the time, right? I just I've got so much of this stuff.
Yeah, no worries.
Because I have a Theodolite, and when you have a Theodolite, you just record all the stuff you do, and then you can just bring it up, right? Right, Taylor? You have a Theodolite, right?
Yeah, do you have a modern one? Because he actually bought a what is it?
I have an old one.
Oh, nice.
It's on lunch
Yeah.
break.
Yeah, he's got the old David White 8300.
Yeah, I mean, any Theodolite will do, right, guys?
I don't know. He said he had
Depends
trouble
on-
recording out of it, so I've never recorded through one. I have no idea.
It's an old manual one.
It is rather difficult to record through these. I gotta admit.
Oh, okay.
Taylor knows. Taylor's got one. She knows.
All right, lads, we are going to wrap up soon, though.
Okay.
We hit the limit right when you were doing the math, though. So I wanted to let you finish out. Is there anything else you wanted to add to that, or you said you basically calculated the same angle, though? More or less.
I you know what? I got 2 minutes, 2 degrees, 31 minutes. So I don't recall what he had, but that was pretty close, right?
Yep, pretty much on the nose. Cool.
Okay, so on a flat Earth, that's what it would be, and I would love to see him measure that. Yeah.
Awesome. I will put in that. I will put in that request to get the exact measurement. Okay. So what you want, like the
just a video of him measuring.
Gotcha. Yeah. Got you. Absolutely. Will do, bro.
Okay. Right on, dude.
All right. So Globe, you still here? Do you have anything coming up this week? Do you want to promote or anything?
I got a debate with someone Monday.
Nice.
I think if it's not on my channel, it'll be rebroadcast on my channel on YouTube. So if anybody wants to watch that, that's coming up around 9 p.m. Eastern. That's about it.
Nice. All right, cool.
Thank you.
8 inches. Thanks for coming on. If you have anything that you want to promote.
Yeah. No, I'm good.
Good. All right, cool. And then.
Oh, yeah.
Jadinsky, thank you. You knew I was struggling to get there. I was like, Jadid. Yes, all right, what's up, bro? You got anything you want to talk about?
Yeah, in closing, like Austin Wissett said, the 2.34 axis was observed on a non-local observation, and that means that it's something way out there, and it's not something that we can, say that is a part of our whole spinning globe. Yeah, we can't. Yeah, it's hard to explain this type of stuff.
Right on. Too many wobbles for one axis, you're saying.
Yeah, you said it.
Gotcha. Taylor, what do you got coming up on the 11th of this month?
I'm going to be presenting on abiogenesis.
Where are you going to be presenting that at?
On EtherCause.
Nice. India, what do you got coming up, brother?
Oh, God. I don't know.
Flat Earth Friday return?
I'll be on Discord. Oh, Friday? We returning Friday? We got Flat Earth Fridays going?
I don't know, but I assume when they do return, you will be there.
Oh, yeah, certainly. I'll be there. In between then and now, I just chill at the politics server and deal with those people. We got a channel over there, so it's an endless stream of, globe champions. Let's just call them that. I'm being nice.
Awesome. Kat, what do you got coming up this week?
I think we've got a little game action going on at EtherCause, and we'll have EtherCause community game night next Monday. But I do want to give a shout out to those people that are gifting the 4 members of Space Audits team, because we are new to this TikTok stuff. But Jean Techman, Proud, Katie Didn't, and Glenda Safkin are all the 4 members on Space Audits team. Thank you guys. However you're joining, for all the gifts and whatever that are sent up. We are new to this and don't know exactly how this all works, but thank you for all who are sending stuff up, and we appreciate coming and sharing the time with us, sharing the live out. Yeah. Thank you all for come to listen.
My boy Xavier sent a lightning bolt and a rose. Very cool, brother. All right, so for the rest of the week, we got Friday events, so that'll be probably a community space or Flat Earth Fridays. Monday will be community EtherCause. Tuesday will be Taylor presenting, and then Wednesday and Thursday will be more TikTok stuff. But before we get to all of that, Sunday will be Dr. Mike Heffron's presentation on Globebusters, presenting the celestial Theodolite. So everything we went over earlier, he's going to be going over in more detail, and I'll see if I can get him to do some supplemental measurements to appease everyone, because those are some valid critiques. So those will definitely be met. Thanks everyone for tuning in. We'll see you guys for the next one. Later.